Alright, today's video, what we're going to go over is the second part, or the other half, of a spring PMA or a fall PMA, whether you're checking an electric heat system, or you're checking a gas furnace, or you're checking the air conditioning system. Because on our service invoices, on the left hand side of the service invoice is all of the air conditioning checks for the spring PMA. At the bottom of it is for the blower motors and air handler and indoor air quality and filter, and on the right hand side is all the checks for your ducts, your coils, refrigerant leaks, things of that sort. So when you're doing a fall check on the system, whether it be an electric heat or gas heat, it doesn't matter. There are some of the things on the electric heat side of it, or excuse me, on the heating side of it and the right side of your invoice that literally don't apply to the electric heat system, but instead of changing the rest of the invoice, basically it's just there and you bypass it. So we're going to start off. I've already done 2 videos. If you have not seen those videos yet, the first one is on gas heat systems on the fall PMA, which I go over the top portion of your fall PMA, and you know this is going to be a heating check because at the top of the invoice on the right it says heat on it. If it's an air conditioned invoice, it's going to say AC on it. The difference in these 2 invoices is going to be everything on this left hand side. So because this is a heat invoice, I've got a gas furnace check here and electric heat check here. Down at the bottom stays the same for AC and heat, and on the right hand side all stays the same for AC and heat. So what we're into right now is we're fixing to go over the bottom section and on the right hand side. If you have not seen the fall video for gas furnaces and for electric heat, please go watch those first, because this is the first portion that when you're going to check an electric heat system, you're going to be on the back end of it now, okay, which I'll probably reference a lot of the stuff in the heating mode. If we're in the air condition mode and we're on this side with the air condition, I'm going to reference stuff basically on the air condition side of it. So if this is the first video you're watching, go back and watch the electric heat and the gas heat videos first, because now we're going to get to the rest of it that will coincide with everything we just did here. Alright. So, where we're going to start at right here is down on the bottom where it says thermostat. Okay? So, the object of this video is to teach you what I'm asking you to go look for when you go do a fall PMA. And when it says thermostat on it, it's going to say okay, unlevel, and broken. Now, it could be miswired. There could be the batteries that are bad in it. So there could be other things on it that, you know, aren't my 3 selections there, but no problem. You know, you check in the thermostat. So the first part of it is go check the thermostat. It's a digital thermostat. It's a mercury bulb thermostat. It's a millivolt thermostat. Whatever kind of thermostat it is, it's just a line item that says, go check the thermostat. What are you checking for? If it's the old mercury bulb thermostat, you want to make sure it's definitely level, because that has something to do with the temperature that you're going to have it set at and whether it's going to register properly. Really and truly, that type of thermostat is going to register properly based on your heat anticipator, which you have to refer back to the other video, which I explained heat anticipators. If it's a digital thermostat, that digital thermostat is going to read your temperatures and work off of your temperatures and work off of differentials, meaning if you have it set at 73, the air conditioning system might not kick on until it's 75 with a 2-degree differential. On the heating system part of it, if you set it at 70 degrees, when it reaches 68 in the house, it would kick on in order to warm up to 70 degrees. Then as the house gets colder again, it's going back down to 68 and turns the air conditioning or the heating system back on to warm back up to 70 degrees. So that's called the 2-degree differential. On digital thermostats, you can set your differential. If you have a 2-stage thermostat, You can set your differential on first stage, which would be 1 degree, and second stage, which would be 2 degrees. So if you have a 4-ton heating system or air conditioning system and you have a differential of 1 degrees and you set your air conditioning system at 73, when it reaches 74 in the house, it's going to kick on first stage, which is 70% capacity, cool down to your 73 setting, and shut off. If it can't handle it, it'll run for 20 minutes, then automatically kick into second stage. Then it cools down to 73 and shuts back off. In the heating mode, it's the same thing. If you have a 2-stage gas heating, you could have a 100,000 BTU gas furnace. The first stage kicks in is W1. You may only get 50,000 BTUs of heat instead of say 100,000, which you gotta have an 80% efficient furnace. So instead of getting a true 100,000 BTUs, you're getting 80,000 BTUs on your output, 100,000 BTUs on your input. You lose 20% of your flue. Your first stage, just call it 50,000 BTUs. Your blower motor slows its speed down. You could have a variable speed, probably would have a variable speed blower motor with that particular furnace. The blower speed would also decrease, as well as your BTU capacity and inch out of your gas pressure. When that is happening, you set your thermostat, say it's 68. So as it goes down to 67 in the house, the first stage may kick on, and you run it at 50,000 BTUs. As long as it's enough to warm your home up and climb back up to 68, it will shut your system off. If it's not enough heat, and your house goes from 68 to 67 now to 66, second stage will then kick in, and then bring it back up to 68 and shut that system off, okay? Now, when I say go check your thermostat, man, this can go into a 4-hour video by itself with thermostats. The EcoNet thermostat is a Ruud thermostat. It is a communicating thermostat. So a communicating thermostat has got a common wire, a 24-volt wire, and they could have a plus and a negative in it, and these are your communicating wires, okay? So when you run a new air conditioning system in a home that has a communicating system and you're running new wire to that outdoor unit, you should run a 4-wire out there. So this would be considered an 18 4-wire is what you're running to the low voltage on the outdoor unit. If you have an old system that only had a 2-wire on it, so this wire here, we'll call it by itself, okay? And we're gonna call this one the red wire and this one the white wire. So you only had a 2-wire going out to the condenser originally, okay? And I wanna put a 2-stage air conditioning system in my house with a communicating thermostat. Well, I don't have 4 wires out there, so therefore I cannot run a communicating thermostat unless I do this. I go put me a transformer in, and I run my L1 and L2, and I get 24 and a common from here, right? So then I bring this common into here, and I bring my 24 over here. This is all inside the condenser. Nothing inside. This is L1 and L2 is going off of your contactor. You're feeding 24 volts into a completely separate transformer that is doing nothing more, nothing less than energizing the circuit board on the outside. Your 2-wire here are now your communicating wires going to your indoor unit. So your indoor unit, we'll put a line here. Here's your furnace on the inside or air handler on the inside. And you're going to have a common. You're going to have Y1, Y2, W1, W2, G, and R. You will also have another terminal completely over, a whole different little deal, that's going to go negative, positive, and it may have a common and an R by itself, or it may not, and it may just be a common and a positive. Okay? That would be your communicating wires. So then you take these 2 wires here and you connect them. negative to negative, positive to positive. And when I say negative to negative, positive to positive, it is not DC voltage. It's communicating wires. It's just a plus and a negative based on their symbol, nothing more, nothing less. Now, data wire means data's coming in and data's coming back out and feeding the thermostat. So then you have a thermostat over here, which is called an EcoNet thermostat on the Ruud system. And the thermostat is going to have a common, an R, a negative, and a positive in the thermostat. So what do you do from here? You take this negative over here, bring it to negative, this positive over here, bring it to positive. Common obviously goes to common, R goes to R. Now you have a communicating system. Your thermostat tells your air handler what to do, which tells your condenser what to do. There could be thermistors on the outdoor unit, which read the outdoor temperature, could read the outdoor suction line. There are sensors, there are resistors inside your air handler, furnace, blower motor, furnace compartment, air handler compartment, that would read resistance of the blower motor, which therefore could tell that thermostat what static pressure this system is at. What CFM that furnace or blower motor is running at. So the EcoNet thermostat, when you go to the setup menu in there, in the diagnostic menu, you can literally see the model and serial number of the condenser, the model and serial number of your furnace, because it's a communicating system. So it has to read what furnace, what condenser you have, or what air handler and what condenser you have. When it reads it, instead of me going to my circuit board on the indoor unit and setting dip switches of how fast or how slow or what ranges I want my blower motor to run at, because there are, say, 10 dip switches in there that I can adjust my blower motor speeds, the ramp up, the ramp down, all kinds of stuff on there as far as how to run that circuit board. If it's a communicating system, they basically took the person in the field and said, look, I know you're probably not going to go set all these dip switches and you're going to ruin my system that we just developed and built. So because I have a communicating system now, the program is going to set all this stuff for you. And it took the stupidity basically out of the field and it just put it into just wire it, and now you don't have to actually think. Literally, I do believe that's what the thinking was when they built these things. Now, the problems you can have with a communicating system is this. You got a broken wire here, or you have the type of wire that's maybe frayed, or the electrical outside, the wire nut that's on it outside is underneath the house and it's kind of frayed and it's oxidized and all that kind of good stuff, and you have bad connections. Then your data, it may not communicate. And if it don't communicate, your condenser is going to say communication error. I mean, not your condenser, your thermostat is going to say communication error. And it will also tell you that it can't read your condenser. How is it reading your condenser? Your data wires going to your condenser is reading your condenser. If you have a bad circuit board out here, can't read your condenser. If your 24 volts out here from your transformer are not firing up your circuit board, it can't read your condenser, there's a communication error. Okay? The S30 thermostat with the Ruud system, with the Lennox system, these thermostats come with a book on them, like, 3/8 of an inch thick of the instructions on how to set up these thermostats. I have a job I'm actually going on later today after 3 o'clock, and it's an XC20 system, variable speed compressor, variable speed blower motor on the inside, and he's still having humidity issues with a variable speed system. You can set your humidity level, your temperature level, and that system has always given it to you. In this particular case, his humidity level, he's saying, will not come down in the house. Okay, so no matter what we're setting this thing at in humidity level, his humidity level is staying like 60% in the house. So I've been back and forth with Lennox in order to try to look at settings and all that kind of stuff in the house to see how we can set this thermostat up for maximum dehumidification. So I've never come across a variable speed system where I've had humidity issues in the house, never. So we're going to look at all that. So again, I'm going over thermostat, and I'm telling you go look at thermostat. Well, it just says okay, broken, unlevel. It doesn't say is it communicating, do they have a transformer on the outdoor unit providing your R and your C. Did you go look at your status of your furnace in the inside, and did you check everything on the thermostat to see that the system is actually working properly? Because if you have error codes on the thermostat, it's going to tell you if the furnace is not working properly. You can go look at everything that system has been doing. It'll tell you the CFM that the system is running at. So that thermostat needs to be understood. It's called an EcoNet thermostat with the Ruud system, or the S30 thermostat with the Lennox system. The Lennox systems used to have a T81 thermostat, and the T81 was the thermostat it was a white thermostat, which was their communicating thermostat. Well, they have gotten rid of the T81 thermostats, the 1081 thermostats, and they've now replaced them all with the S30, so you can't even buy the 1081 thermostats anymore. They're all S30s. Now my cost of this thermostat is almost $600. So the cost to the customer to purchase this thermostat is over $1,200. Now guess what you have to do to install the thermostat? Now you got to know how it works. So here you are, I send you to a house to go install an S30 thermostat, and you don't know what the hell this thermostat does, how it does it, or what it does. How long do you think you're going to be there if you're going to read a book this thick trying to figure out the installation instructions?
Go on vacation.
Okay? Well, luckily, they're extremely simple, because it just gives you like a computer that says, okay, next do this, 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 okay? But when you go to the setup of it, if it's communicating, it's going to read there as a condenser. It's going to read your model number of your air handler on the inside. So as long as you connect these wires properly and you don't have any frayed and broken wires and everything, it will literally set that system up for you in a quote-unquote standard everyday mode. Standard everyday settings. Now, will it program the thermostat for you to turn it on and off whenever you want it to? No, you got to go into the programming and set the programming, which is icons. It's, like a Microsoft, icons on your tablet, basically. That's the way it is on the thermostat. And you go into this icon and it sets programs up. Well, the programs you can set up can be 4 times a day. You can have the furnace or air conditioner turn on and off at different times. You can set humidity levels. You can set a program for your fan that if you want your fan to come on at between 2 and 3 o'clock every day, it can do that for you. Okay, you can set your humidity level. You can set vacation times of when you want to take a vacation and actually have the thermostat raise the temperature up while you're on vacation and come back down beforehand. I mean, there's so much, I'm going to call it stupid crap on these things that you can do on these thermostats that nobody ever touches, okay? Rarely, I'll put it that way, okay? When you have an issue with the thermostat, that's when you start having to learn the program of that thermostat and all the different parameters that you can set on the thermostat, which are a ton of different parameters you can set on it, a ton. How soon does the blower motor come on when you turn the air conditioning system on? 3 seconds, 5 seconds, 10 seconds? How long does the blower motor take to actually shut off? Does it shut off immediately? Does it go 5 seconds, 10 seconds, 20 seconds, 30 seconds before it shuts off? Does it ramp down? Does it go from 100% to 75 to 50 to 0? Does it go from 100 to 0, 100 to 50 to 0? You can set all this crap up on your thermostat. Now you got to go into the setup menu of it, the installer mode, whereas you're quote unquote the installer, right? So you have to set all this stuff up on that thermostat and tell that thermostat that I want you to do this, and I want you to read this, and I want you to measure this, and when you measure this, I want you to do that when this happens. You're telling that thermostat to do all that crap. It is intriguing. It's scary when you first look at it, because you literally pull a book out this big, and every time you pull a book out this big, you're going, oh shit. What the hell am I getting into now? I don't know anything about this damn thing. Tell you what, man, let me take this thing home first and let me spend 2 hours on it and go over the whole thermostat. That way when I come back, I don't look stupid. Okay, well luckily there are videos on the EcoNet thermostat and videos on the S30 thermostat that you can do all this stuff online. There's literally a modular type of deal where you can get in and literally do all this stuff and learn how the thermostat works. Now, unfortunately, 99% of people don't do that. They just go to the house and look stupid in front of the customer and can't figure anything out. Okay? So, there is number one that I went over, thermostats. So, our little line items that we go through do not go of just, here's 14, here's 15, here's 16. There's always a story in every number. There's a history in all of it. Also, while we're on thermostats, if you have a heat pump, you have to have a heat pump thermostat. You can't put any thermostat on a heat pump because your typical terminals on your thermostat or on your air handler itself are going to be your common, your Y1, Y2, W1, W2, GR, O/B, DH. Dehumidification, O/B is your heat pump signification. Then on that thermostat, you have to decide and figure out OB is if you have a heat pump, does it energize the solenoid in the heating mode or the cooling mode? When you figure that out, then you will select whether you want it to energize on B or O. So if you install this thermostat, you turn the heat pump on, and you have it on cool mode, and you walk outside and it's blowing cool air outside, and it's set on B at that point in time, go in there and take the thermostat, go to this setting right here, and switch it over to O. Then you'll actually turn the unit off, turn the unit back on. When the unit comes back on, you will blow warm air outside and cold air inside. If it is set in the wrong setting, then you will run heat when cool is supposed to run and cool when heat is supposed to run. Okay? DH is for dehumidification. You'll bring a wire over to it. Now, if you have a communicating system, you're not using any of these things. You just have a smart thermostat that's reading humidity level in the house. It's a humidistat as well, and it senses the humidity level at 62% relative humidity, and you want it at 50. It sends a signal to the condenser to kick up its BTU capacity. It sends a signal over to the G to lower the blower speed, and it's in dehumidification mode. It lowers the blower speed about 20% in dehumidification mode to make the coil colder and dehumidify the house. R is your 24 volts. G is your fan. W1 is heat in first stage. W2 is heat second stage. Y1 is your cooling in first stage. Y2 is your cooling in second stage, and C is your common. While we're going over thermostats, let's go and say, how do you wire this thermostat? So when somebody tells me, I ask them which wire or which code is for cooling, and they go, yellow wire. And I go, you're wrong. Now, 99% of the houses you go into, the yellow wire will go to Y1. So that would be a yellow wire. That's how you're going to wire this thing. So if I ask you which one is your cooling one, you should tell me Y, not yellow. Y. The reason I say you tell me why is because if I run a purple wire to this Y1, is it still cooling? Yes.
Yeah.
So the color of your wire has nothing to do with the terminal of what it is representing. Y represents cooling, W represents heating, G represents fan, R represents 24 volts, C represents common, OB represents reversing valve, DH represents dehumidification. W doesn't represent white. R does not represent red. What color wire are we going to run to the R, guys? We're going to run a red wire. Now, if I decide to run a white wire to the red, and I want to run a red wire to common, which is normally going to be a brown wire, normally, okay? But I'm going to switch them, and today I'm going to go ahead and I'm just going to run a white wire to R, and I'm going to run a red wire to common. Will that make a difference when you wire up the rest of the system and somebody else outside is thinking that you wired it as common would be white or brown, okay, brown in this case, but I don't have a brown wire now, so I'm going to make it red, okay? So I put red to common and I put white to R, which would be common on your outdoor unit. Will it make a difference? If it's just a contactor and swapping those two, it makes no difference, okay? If it is a communicating system, then it makes a difference because you have to have a ground outside. And the board has got to be grounded. So you can't put a ground and run 24 volts to common over here because it's not going to be right. Your polarity is off. See how now it makes a difference? If it's just a contactor outside and I have these two swapped up, does it make a difference? No, it don't. But everything else that this system is going to do, the answer is yes. And the only reason it wouldn't make a difference, because if I supply 24 volts to a coil, does it make a difference if the 24 comes from here and a common comes from here, or vice versa? No, it don't. On a communicating system, it makes a difference. On a circuit board, it also makes a difference. Your circuit board has got to be grounded. So your polarity has got to be correct. In the old days, go to the electricity in your house. The electricity in your house, you have a black wire and you have a white wire when it comes to feeding 110 volts somewhere. Well, your 110 volts is being fed, close the door please. Common wire is going to be your white wire, your ground wire is going to be the copper wire, and your black wire is going to be your 110 volts. So if you go over to that system, and I'll draw this out because this makes a difference. So here's your L1 and here's your neutral. L1 is going to be a black wire, neutral is going to be a white wire, and then you have your ground, which is your copper wire. So when you go into a switch, which is going to be a normally open switch, when you go into the receptacle, the whole casing of it, and you bring this black wire in, you are supposed to bring it to the switch, okay? Then your white wire would come in and it would basically, I'm going to call it be wire nutted right here. And then now this comes down to, I'm going to make your furnace right here, and it comes into here, so this is your white wire, this is your black wire, okay, coming into it. Well, coming from your furnace now, there's going to be a black wire coming in, a white wire coming in, and then there is a green wire for your ground. So your ground has got to come in and connect ground. Well, you know ground's going to be connected to ground, no big deal. Okay? Now, think about coming out of your switch right here, and I don't have this wire come straight. I literally have a wire coming from my switch on my side of my closet, and then that switch, that wire goes into my furnace. So now I'm gonna go ahead and I'm gonna do this. I'm gonna hook my white wire to here, and I'm gonna hook my black wire over here. Well, I'm coming into my furnace. Will it still work? It's an alternating current. Alternating current does this, right? Makes it a circle. Yes, it does work. Where your problem comes in is in your circuit board, because it's going to give you error codes that your polarity is reversed. Okay? So now when you come into your actual furnace itself and you hook black to black and white to white, well, you swapped them up over here. Or somebody did that you didn't look in that switch. So now when you go run your furnace and it gives you error codes and the furnace doesn't run and it doesn't sense that there is a flame. Because what does a flame sensor do? It senses a flame through flame rectification through a ground. Well, if your power is reversed polarity on your circuit board, then you're not getting the ground through your flame sensor, and it's not going to sense that there's a flame. And it will give you a code that the code is going to be polarity reversed. Check your polarity. What does polarity mean? It means your voltage is going this way instead of that way. That's it. Okay? So all of this is stemming from the thermostat, right? Your thermostat check. All right? So communication error. What does communication error mean? That these two wires coming from here, you're not communicating from your circuit board to your outdoor unit. So you pull these two wires off your outdoor unit and you check continuity in the wires, make sure you don't have a broken wire. Now, on a communicating system, we really and truly want to run, and I say want to run, I don't say, not saying we have to, but I'm going to say we want to run shielded wire. And the shielded wire basically is going to stop a lot of the interference in that wire for the data processing, okay? So this wire out here should be an 18-4 shielded wire. Should be, okay? So that's what we started running on our two-stage systems that have variable speed blower motors communicating thermostats. When you go to your thermostat on your wall, if you do not have a communicating thermostat, but you have a two-stage air conditioning system, okay? You have to know this kind of stuff. I mean, you got to know that that furnace is a two-stage furnace. Well, how do you know it's a two-stage furnace?
Got two negative pressure switches.
Two negative pressure switches, very good. How do you know it's a two-stage condenser? They don't have two compressors. Some of them do though.
Wouldn't they have three wires going out there?
No.
Two-stage compressor?
Yeah. How do you know it's a two-stage compressor?
It'll have a secondary valve that would need to be
Solenoid
energized.
They don't have a solenoid valve on the side of the compressor unless they do have two compressors, because some of them do. The old train units had two compressors in them. Some of the old 18-SEER root systems had two compressors in them. Commercial systems will have two compressors in them. Okay, two 3.5 ton compressors or 4 ton and a 3 ton, 3.5 ton compressor for a 7.5 ton system. Okay, in residential, 90%, 99% of the two-stage systems will have a single compressor, but it's going to be a two-stage compressor, which on the side of the compressor there's a solenoid valve that two wires go into that energize the solenoid valve and release or increase the actual pressure of refrigerant running through there. That adds load basically or releases load for that
So for the
refrigerant.
two-stage, don't they have the TXV and a solenoid valve, correct? Or just a solenoid valve?
It would have a TXV inside for sure, but not every one of them because
I'm
good.
talking about for the condenser.
The only time it has a TXV on the condensers is if it's a heat pump.
Okay.
So the one you seen the other day is a heat pump.
Alright.
So the reason they have a TXV on the outdoor unit is what? Do you know? Yes or no?
Yeah, because during the heat pump, the function switch. So like that's gonna be,
Yeah.
you know, your low side.
The outdoor unit is now your evaporator coil
Yeah.
outside. Okay?
Yeah.
So if you think about that lady you went to the other day, Kelly Bowe, been a customer of ours for 16, 17 years. She constantly has problems with that system leaking refrigerant.
Yeah, she told me she changed the evaporator. This is gonna be her third time.
Yeah, okay. But since you have a heat pump and you're reversing refrigerant flow and your outdoor unit is now your evaporator coil, tell me why you're not getting leaks on the outdoor unit, you're only getting them on the inside system. You have a heat pump, so you're reversing refrigerant both ways, right?
Mm-hmm.
Why is her leak only coming in the evaporator coil? I'm going to give you the answer. And it's because she has a foamed attic. And it's creating chemical vapors in there that is literally corroding the copper and eating the copper in the tubing.
You saw that it was like so many leaks on the system. It was like so rusted and it was crazy.
Yeah, it corrodes it. It's
Yeah.
just the chemical, the VOCs, the volatile organic compound in the air is corroding those coils.
That was the purpose for the coating of the coil.
That was
first.
the purpose for the coated coil. The coated coil was supposed to stop refrigerant leaks on that coil with the coating on it. Okay,
Yeah.
well they gave us a new coil, has no coating. In the next few years, should be changing the coil again.
Yeah, I learned a lot from that system. Seriously.
Yeah,
Yeah.
yeah. So this unit here, she's got two systems. One downstairs in a closet, one upstairs in the attic. She has never changed the coil in the closet.
Yeah.
Not one time. Never has a problem with the downstairs system.
At all.
Only the upstairs system, because that unit is in the attic and it is a shitty job as far as the foam is concerned in that attic, but the chemical vapors in that attic is what is causing the corrosion of that coil. Absolutely.
So like the dehumidifier is not doing anything to help?
Dehumidifier dehumidifies.
Alright. I
It
was just
doesn't do
asking.
anything with chemical vapors and VOCs. I don't know what to do, to be honest with you. I don't know what to do to destroy VOCs that are eating copper and aluminum. I don't know the answer to that. Now, was the coil you put in aluminum or was it copper?
It was aluminum. It was just
Well,
regular-
hopefully because it's aluminum and all the other ones have been copper, one you took out was copper?
It was coated. I
Couldn't
couldn't
tell.
tell.
Our industry has changed from copper to aluminum, a lot of it because of the cost of copper today, okay? So now that we're changing this coil and it's aluminum coil now, maybe the type of material being aluminum does not corrode with the VOCs in that particular attic. Maybe. We'll see. Hopefully she won't have any more problems with it.
Quick question. Does all the foam material have the same effect on cars, have the VOCs in it, or just different types of foam?
Well, it could be the mix of the foam or it could be that batch of foam too, because I used to do foam insulation and there is a side and a B side and they actually interact through your gun, a heating gun, and when they come together and you shoot your gun, it comes out just hot as shit and it interacts and when they grab each other together and they foam up, okay? The actual chemical imbalance could be setting off a lot of VOCs, okay? In my attic, my own house, I foam my attic. I've changed my coil twice in my attic in 10 years. My downstairs one I changed one time, and it's in my garage area, but it still has foam, okay, in the garage area.
You got a 90% efficient furnace?
I do. I have a 98% efficient furnace in my attic. And downstairs I have a geothermal system. Yep. Okay. All right. So we're on number one, right? So again, we are going over the additional part of your service invoice that after you check your heating system, this is your heating system for electric heat we just checked. So now we're down here on number one now. We just checked the thermostat, which went into a 30-minute rant on everything else that from electrical that affects your thermostat because of the polarity, right? So just because I say again, okay, broken, unleveled, does that end your check with the thermostat? No. I just opened up a whole bunch of shit you need to be aware of. I went to Roy's to go over a job yesterday, and he asked me, going back to this, he says, I found out what the problem was at my camp. He says the thermostat, like in the middle of the day, just goes to 85 degrees. Well, why will it go to 85 degrees in the middle of the day? Simple. His camp is out in Cocodrie. They had a hurricane out there. They lose power. Well, ever since they got power back out there, his air conditioning system will go to 85 degrees in the middle of the day. Why? Because sometimes you got to go back to the thermostat and you have to set the time on the thermostat. So the one down here, downstairs, I constantly have to reset the time on that thermostat, because if we get a power surge or we lose power for 2 minutes, then the girls will start going tomorrow morning. They'll go, it's hot in here, it's hot in here, 7 o'clock in the morning. Well, the program is set basically for 6:30 to go down to like 71 degrees, 73 degrees, so you're nice and cool when you come in. Well, 8 o'clock, it's hot in here, it's hot in here. Can somebody go check the air conditioner? I said, why don't you go check the thermostat to see what it's set on first? Well, you go to the thermostat and it's set on 78. Why? Because it changed the time on the thermostat and it thinks it's 3 a.m. That's why. So you change the time on the thermostat and you're telling it it's now 7:30 a.m. and it goes back to 73. I constantly have to set that one downstairs, constantly. So he tells me yesterday, I figured it out. He says the thermostat keeps going to 85. He says, I don't know why. I said, well, I'm going to tell you why, because the programming from it from day one was probably set at 85 degrees, just from the factory or whatever. I said, go into your programming of the thermostat and set your program again for every day, Monday through Sunday, because he likes to keep it at a certain temperature or whatever. And he's rarely there during the week, so you can just, like at my camp, I have it set at 78 when I leave, and then I have it set at 73 when I'm there. Well, I'm not there all the time. So literally, I actually took the program and I bypassed the program and I just put it to manual. So as I walk in my camp, I walk over to my thermostat, set it at 73. It stays at 73 until I leave on Sunday, and I bring it back to 78. There's no need for me to have a programmable thermostat at my camp. None. Because when I get there, I'm going to set it wherever I want. And I don't know when I'm going. I could go Saturday morning, I could go Friday night, and there's no reason for me to keep it on 73 every weekend if I'm not there every weekend. So a programmable thermostat, guys, really and truly is useless unless you literally have a program or a set schedule that you do. I leave at 7 o'clock every day, I'm home for 5 p.m. I set it at 7:30, it goes to 78. At 4 p.m., it goes to 73. So when I walk in the door at 73, in the middle of the day, it's 80 degrees in my house, and I don't care because nobody's here other than the dog. And the dog can survive at 80 degrees in air conditioning, okay? Without a problem. They sleep just fine. I actually have my camera, and I watch them sleep just fine at 80 degrees. But my energy bill doesn't go up because I'm cooling my house to 73 degrees when it's 900 degrees outside. See where I'm at? Okay? What do you have to do every time you install a thermostat? Every time you install a brand new system, what you have to do on a brand new system, nobody lives in this house right this minute as a rough-in, or you just did a change out. You have to go on a change out, you now have to go ask the customer, what do you like the temperature setting on your home? Oh, I don't know, honey, what do you think? Okay, 73. Well, do you like it colder at nighttime? Do you have a set schedule that you're gone on a regular basis? No, I just want it on 73 all the time. My wife's here all the time. Okay, you know what I'm going to do to the program on the thermostat? I'm going to go to the program on the thermostat, and for air conditioning, I'm going to set it at 73 Monday through Sunday. Every schedule is 73. What heating temperature do you like? Oh, I don't know. I guess the same thing. No, you don't like 73. 90% chance you probably don't like 73. So you go think about it. In the heating season, do you run the heater a lot? Oh, I don't like the heater. Well, then you don't want it on 73 because you're burning up in your house. Well, how about 68? That's about normal, okay? So I'll tell you what. how about if I set your heater at 68? Okay, so go to the thermostat, and they just told you they're not somebody that's gonna go play with a program on the thermostat. So go to their thermostat, go set every program on the heating mode at 68 degrees and at 73 degrees for air conditioning. Then you go ahead and you hit the manual on that thermostat or bypass program or whatever it's going to say on it, and you make this thing a manual thermostat, and you go, come see, ma'am. Hit this button right here that says up on it, and this one that says down on it. You see this number here? It says 73 in here. This is the temperature reading in your house. See this one here? This is what I have it set at, 71, or vice versa, whatever you're talking about. If I hit this button down here, it goes to 70 and 69. If I hit this one here, it goes 72, 73. See that? Yep, this is how you adjust your thermostat. You see this little lever right here, and it says cool over here, and it says off, and it says heat. If you put it on cool, when you push this down, the air condition comes on. When you push this over on heat, when you push it up, the heater comes on. Do you understand how that works? Yes, I do. Okay, great. Let's go a step further with this. Go a little more technical, okay? You want a program on your thermostat. This is immature, stupid shit, okay? I want a program. I'm intelligent enough to figure crap like that out. No big deal. I'm not going to go that just stupid for somebody. But on it, my dad, this is what I will do for my dad. See, Dad? Push it to the left. Well, I can't see it. Well, just remember, left is cooling and right is heat. Okay. So then he can't see it, but he can push it left. That's what you got to do with thermostats, okay? Now let's take a step up. You're going to play with your thermostat a little bit. You're probably going to set the program on it to what you like it at. But before you set the program on it, I have now got to teach you the program. I have to now go into the program, and I got to go, let me show you now. We're going to set this thing at 4 times throughout the day to kick on different temperatures. So what time do you wake up in the morning? 4:30 a.m. Ma'am, what time do you get out of bed? 8 o'clock. So I'm giving you my program, okay, for my house. So my wife leaves basically at 7:30 in the morning, okay? So I leave at 4:30 in the morning. So if I have my program set and I have the temperature go up when I leave at 4:30, she's hot, you know? So who wins now? She wins. Because she's the last one out of bed. So after 8 o'clock or so, I can raise that program up now and say, okay, from 8 o'clock, honey, what time are you getting home? Because I don't get home to 8, 9 o'clock at night. Well, she gets back home at about 4 o'clock. So 3:30 or so, I can take the thermostat and bring it now from 78, because I raised it up to 78 at 8 o'clock in the morning, and then because she gets home at 4 o'clock, at 3:30, I bring it back down from 78 down to 73 again. And then I like it a little bit colder at nighttime when we're fixing to go to bed. So at 9 o'clock at night, I'm going to go from 73 to 71. Then at 4 a.m. in the morning, I'm going to keep it at 71. But at 8 o'clock, it's going to go back up to 78. So there's 4 times I can change that thermostat setting, okay? So now, here's what I am going to do with this customer. And you have got to do this with this customer. If you install this thermostat, you have got to teach this customer how to work the thermostat. Then you have got to hand them the book. But more than anything, you have got to teach them how to work that thermostat. Hurry up on real quick. I'm doing a video. It's going to be a little while. What do you need? I've never seen this job, so you're gonna have to call Glenn and like go over it with him. I literally don't know how much you gotta cut and how long is it gonna take. Alright, so go call Glenn and y'all have to talk, cause I've never seen this job, buddy. Alright, well, alright. Okay, so here's what I'm gonna tell you then, based on your knowledge and your experience in working with me. If this is a lot of work that needs to be done, and you feel that, you know, we need to charge him an extra $200, $300, $400, then call Glenn and say, look, in order for us to cut all the sheetrock, we need to charge him an extra couple $100 to do this. And then between you and Glenn, y'all decide, because I've never seen this job, so I literally don't know what you're talking about. And then y'all just make a decision, and whatever y'all decide is what it is. And I'm fine with it, okay? Thank you, man. So the good thing about it, I can edit all this, okay? So where was I, guys?
Programming a thermostat show.
Okay.
Teach them how to do
So
it.
programming the thermostat. So I have to take the lady and take the guy. Now the first thing I have to do is before I even go get them, I gotta install the thermostat and I have to play with the thermostat and I have to get it to where I understand it. So I don't look stupid in front of the customer. I act like I really know how this thermostat works. Well, I've never installed this specific thermostat ever before, so I do not know how it all works. But it won't take me but 5 minutes to figure it out because they're all pretty much the same. Okay, and I'm not stupid, so I can figure it out. But I gotta go to the program and I gotta go, how do I figure out how to change every date, how to change every day, how to change every time? Can I set it on Monday through Friday and then Saturday, Sunday by itself? Or do I set Monday, Tuesday all the way through Sunday on a separate day? Do I copy a day and move it to the next day? Do I set Saturday at one day and Sunday at another day, but Monday through Friday is all the same? It's easy to figure that stuff out, but you got to figure it out before you bring the customer over there. Because when you bring the customer over there, you have to say, okay, I'm going to show you how to set Monday through Friday and then Saturday and Sunday. So you go ahead and you show them how you program it, and they're sitting there looking at you. And it's going right over their head. Then you go, okay, now I'm going to do the heating side. But I tell you what, you're going to do the heating side. So you step here and you do it, and I'm going to just walk you through it. Like anybody, if you sit and watch me do it all the time, as opposed to you physically doing it, which one's going to register in your head?
You physically.
You're physically doing it all day long. Okay? So then what I'm going to do after you set the heating thermostat, then we're going to go back into the cooling mode, and I go, tell me how you raise the thermostat if it's too cold in here. I raise it up here. I lower it here. No problem. Now, remember your program on this thermostat, we're 2 o'clock right now, and you set the program at 4 o'clock that you're going to drop it down to 73 degrees. So it's 2 o'clock right now, and we have it set, let's just say the program at 78, okay? So I get home early today, and I walk in there and I go to the thermostat because it's 78, and I'm home 2 hours early. I go to the thermostat and I lower it down. I'm going to say down to 68 degrees because the wife's not home and I like it cold. So I want it 68. Well, wife gets home at 5 o'clock and she likes it 73. So I got 2 hours that I want to make it cold. So for 2 hours, I drop it down to 68. When 4 o'clock rolls around, the program's going to take right back over and it's going to bring it right back to 73 by itself. So remember, when you go to that thermostat on a program, when you have it in the program mode, you raise the setting or lower the setting on the thermostat, and it's only for the time period until the program changes again. If you have it on hold, then whatever you set it at, like at my camp, I have it on hold. I just leave it on hold. I never touch the program. I walk over to the thermostat, I set it on 73, I close the deal up, and I walk away from it because I don't take it off a hold. I never take it off a hold. So I go 73 and then 78 at my camp. At my house, I never touch the thermostat. I've been living there 10 years, and I could probably count on one hand, how many times I have literally touched my thermostat in 10 years. I don't fool with it. I have a thermostat in my living room and I have a thermostat in my bedroom because I have a zoning system that moves my airflow back and forth. So at nighttime, my thermostat in my bedroom goes down to 71. During the day, it goes up to 78. The living room, because the wife used to be home all the time, the living room would go down to 73. Well, she's not in the bedroom all day long. So she's in the living room or doing shit in the living room or whatever, right? When I get home at nighttime, I want it 73 in the house. And then when we go to bed, say 10 o'clock at night, 71. Till 8 o'clock in the morning again. Then I can raise it up in the bedroom again. Okay? Now at nighttime while we're sleeping, nobody's in the living room. I actually take that thermostat after about 11 o'clock and I raise it up in the living room. So my airflow can go over here now. Just adjust it. Please remember, if you do not set the program to the thermostat, and the program comes set at 78 degrees, and you don't set the clock on that thermostat, you are going to leave that thermostat set at 73 when you leave. And you're going to get a call back the next day and say, at 2 o'clock in the morning, it was like 80 degrees in my house. So they get up the next morning and they turn it back down to 72 and it's cooling again. And then the program, because the clock's off, right? At 2 o'clock in the morning, it changes it back to 82 again. And they wake up sweating. In 22 years of being in business for myself, I've gotten that phone call 1,000 times. I mean, just 1,000 times. And they go, well, y'all installed the thermostat. Why didn't y'all tell me? Because the technician who installed it was lazy. And he probably didn't know how to set the thermostat, so he just said, okay, it's installed, ma'am, it's running, I checked the air conditioning, it's cool. And he didn't tell you how to do it either. So he didn't take the 10 minutes to literally sit out in the truck, read the book for 5 minutes, walk in, figure it out. And literally these thermostats are so simple to understand. When you sit there in front of them for a few minutes, just a little bit of common sense, you can walk through these thermostats by yourself without the customer even knowing you're trying to figure it out. Because they can walk over there and they go, what you doing? I'm just checking all the parameters of the thermostat. They don't know you're actually just trying to figure it out. Just checking the parameters of the thermostat, making sure everything's working fine. Okay, I'm going to let you know once I set everything and figure out how everything's set up for you. I'm going to bring you over here and I'm going to have you learn how to do it. Okay. So they leave you alone and you finish figuring out how to do it and then you bring them over. And you have them switch it from heat to cool. And you have them adjust the program on the thermostat. Have them do it. Have them change the humidity setting on the thermostat. Have them put it in the auto mode or cool mode or heat mode. Have them do it before you leave. Alright? Alright, we're done with number 1. We're going to number 2 for probably another 2 hours. Nope, this is only your blower motor that we're going to check out. I want to know if your blower motor is okay. Loose bearings or noisy. What else am I looking for on that blower motor?
See if it's clean or dirty.
See if it's clean or dirty. I also want to check the amps on my blower motor. And here's something I don't have on there, which I should have on there, but when you say blower motor, it has to be an automatic check anyway. What are you checking for when you check a blower motor? What other piece do you have on there? But the capacitor. Now, I don't have a check for the capacitor. I need to redo this and put a check on there for the capacitor, right? Okay, but if I'm telling you, go check the blower motor, what am I telling you?
Check everything associated with it.
The motor don't run without the capacitor, guys. Unless it's a variable speed, don't have one. So go check your capacitor. Don't just go, yep, blower motor's running. Well, what about the capacitor? Oh, hold on a minute. Let me go check that now. What are you reading on the capacitor? You're reading the microfarads on the capacitor. So your capacitor may be a 5, maybe a 7.5, 10, 12.5, 15, or 20 microfarad capacitor. So you can't assume every one of them's a 10, everyone's a 5, everyone's a 20. No. Based on the horsepower of that motor, resistance, the whole 9 yards of that motor, you're going to put in voltage as well. Because sometimes if you have 208 volts or 240 volts on a blower motor, will also determine what capacitor to put on there. Okay? Also, your blower motor, depending upon the speed.
Ask you a question real quick.
Shoot, hurry up.
Rewrapping boxes, a price on it, like 7 boxes.
$40 a piece.
Okay, thanks.
You're checking amperage on the blower motor. Well, hell, I just have on the blower motor here, okay, loose bearings and noisy. I'm not asking you for the amperage on it. Should you go check the amperage?
Yeah.
Yeah, okay. Should you write the amperage down somewhere? Yeah,
Yeah,
literally,
it's
you could write it
down.
over here in other. Blower motor amps, BM amps, 6.2. Okay. Now, how do you know if the blower motor is actually working properly from the amperage of the motor? What if you draw more amps than what it says on the motor itself? And what if that motor is running just butt hot, just hot as a sumbitch? Well, it's very possible that blower motor is going to go out on you. What if your capacitor is weak and causing your blower motor to run hot too? You got to replace your capacitor. So again, number two, what I'm talking about here on a blower motor, I'm asking you to go check a bunch of stuff that it's not written on the paper. That's the reason for this video, is for me to tell you, this is what I need you to check on a blower motor. So Kirsten, did you check the capacitors on the blower motors that you did the heating checks for the other day?
No.
Why? Because I didn't write it for you. Right?
Mhm.
So now that I'm telling you, when I tell you to go check the blower motor, do you check the capacitor when I have you do a PMA for the air condition?
Both.
You do, because I actually have a line item that says capacitor, don't I?
Mm-hmm.
So if I don't tell you to do it, that means you don't do it. That's human nature. That's the reason, again, for this video. Because there are more things that I see, that I think about, that when I write this down, I know if I go check a blower motor, I gotta check the capacitor. To me, that's common sense. I do air conditioning work. I know if I go check my blower motor, yeah, I'm gonna listen to see if it's noisy and going, rah, the whole time. But I know when I go check a blower motor, I have to check the capacitor. I have to. It's sitting right in front of me. I take 2 wires off of it and test it. Did you check the capacitor when you checked the system?
No.
Why? Again, same thing, right?
Again,
'Cause I didn't give you a checklist.
You didn't tell me, but common sense should dictate you check everything that gives you specifications for the motor. That
So-
would mean amping, that would mean...
So Gage, I will never have to tell you to check your capacitor, right? Because when I say blower motor, what does it mean?
Everything to do
It
with
means
it.
blower motor and capacitor. Okay? So if you're doing a heating check, well, right here when you do a heating check, it has blower motor. If I have air condition, well, the bottom part of it says blower motor. That means check your capacitor too. Okay? So I'm glad that we just went over number 2 on blower motor, and we just caught a whole bunch of problems that we were gonna have, that you didn't check the capacitor and the capacitor was weak, and you walked away from a bad capacitor, a weak capacitor, and the blower motor fails because you didn't check it. Make sense, guys?
Yes.
That's
Yeah.
why we're doing these videos. That's why we do these classes. That's why if you go from install, we're gonna say, to do service work, and somebody is trying to train you of every little bitty thing they want you to do, if they don't write every little bitty line item down for you to do every little bitty thing, put your meter here, check an amp here, check this, check that, you don't know to do it. And if you don't know to do it, you're not gonna do it. End of story. Let somebody give you a protocol, just to follow this protocol every time you go. That's why I was telling you, Gage, when we started this thing, when you look at this line item, whatever this line item is, it can't mean drain line. Okay, yeah, my drain line's there. No, I'm not. I know your drain line's there. Go check your drain line. It looks fine. No, go look at it and see if it actually goes downhill the whole time. Go follow it all the way to the end and see if it actually terminates properly. Is it insulated all the way through? Is 20 feet of it, the last 20 feet of it, is it a black hose? As opposed to the PVC pipe that goes all the way to the black hose. Well, you checked off on here and it said drain line and it said, okay. It And I go back over there and I go, Gage, what are you doing? I got 25 feet of hose that goes outside that's connected into a PVC pipe that the hose is pushed over. It's not hose clamp on or anything. Drain line's clogged up the very next day, and you told me the drain line was okay. And you go, well, it was fine while I was there. And what you're telling me is it wasn't backed up while I was there. But what I'm asking you to go look for is, go look at how the drain lines run, and if it was run in your house like that, or if you were doing a brand new installation, would you run it like that? If you were doing a brand new installation, would you go, I think I'm gonna run like 3/4 PVC pipe and then I'm gonna tie it into a black hose and then stick the hose into a drain pipe and drill a 3/4 inch hole in the drain pipe and stick the hose in there? I think that's the way I'm gonna do it in my house. Would you ever do that? The answer is no. So therefore, when I'm asking you to go check the drain line, those are the things I'm asking you to go check. So when I say go check the blower motor, what are you going to go check for now? What's going to pop in your head every time I say blower motor now? That capacitor stuck on the side of the blower motor should mean, oh yeah, he told me to check the capacitor too, because it's attached to the blower motor. And it is definitely attached to the blower motor, so that's what you need to check. It doesn't even say amperage on there. So that means you're not going to check the amperage? Did you check the amperage of the blower motor?
Yeah. I mean,
Okay.
you got to, like when you put it in heat mode, my amperage already on there, so I check it for the blower motor, then it switches to heat. You get your 42 amps.
Okay.
Or whatever, you know.
Okay. But even though I didn't tell you to check amperage, you checked it.
Yeah.
Okay? But the thing that actually makes the blower motor run, the capacitor, so if it's weak, it's going to make the blower motor run hot. You didn't check that. See where I'm at?
Yeah.
Okay. It's all part of learning, man. All part of learning, you know. Blower wheel is your next one. Well, before we get to the blower wheel, what is loose bearings? I'm going to tell you how to check a motor. If you actually pull that motor out and you sand it down and the shaft is sticking up, and you take that shaft, if you do this with a condenser fan motor or a blower motor, and you take that shaft and that shaft moves back and forth, it just kind of rocks a little bit, you got bad bearings in that motor. Okay, that motor should just be tight as could be. All right, noisy. A blower motor noisy is making all kinds of noises and squeaking sounds and all that kind of stuff. Let me tell you what a blower motor noise is not. You know what that is? That is a blower wheel imbalanced. That could be the hub on the blower wheel that's actually turning faster than the wheel itself. So the hub is pressed onto the blower wheel from a press. And that press, therefore, when you turn the blower motor shaft, the hub has a set screw on it for the flat part of the shaft that then turns the blower wheel. If the press on the hub, or weld I'll call it in some cases, if it's welded good or holding good, then the blower wheel will turn just as fast as the blower motor. If that connection gets loose, then the actual hub will spin faster than the actual blower wheel itself, and it will make some horrific noises. I mean, just as loud as can be. I mean, if you're standing next to it, you can barely hear somebody talk sometimes. That's how loud it would be. So I've made that, or had that problem where I went and changed the blower motor because the bearings are bad on your blower motor. So you know what I did? I went out in the truck and I got a brand new blower motor. I put in a brand new blower motor. I put it in, turned that system on thinking it's going to be quiet, and what did it do? Rah! And I'm going, what the hell is going on? When I worked for a company, I was probably a month, 2 months into the business. I called my boss up at that time. It was like 11 o'clock at night. And I was on a service call, right? And he goes, and I told him, I says, dude, this thing's making all kinds of noise. I woke him up, middle of the night, 11 o'clock at night. I woke him up. And I said, I went and changed the blower motor. And I says, but it's still making the same sound. I said, here, listen to it. So I had the phone right there by the unit, right? I said, here, listen to it. So I put the phone over to the unit. I said, man, what is that? He goes, it's not your blower motor, it's your blower wheel, your hub. So I ended up changing the blower wheel the next day. System was quiet as can be, never made the same mistake again. There you go. Okay. So, blower wheel is number 3. It says clean, dirty, and filthy. So we just got finished saying blower wheel. You know what I didn't say on the blower wheel? Which you can go back to the blower motor? Noisy. Imbalance. Because one of the things I want you to go do when I say blower wheel is I want you to run your fingers through the cups of the blower wheel. If you know that blower wheel is dirty and the customer's standing right there by you, I need you to go, here, let me show you something. Watch this. Reach your hand in on the left-hand side, which because the blower motor is normally on the right-hand side, and then run your finger through one cup of the blower wheel and pull out a little piece of dirt and dog hair and whatever. And sometimes it's matted on there. It's like you can't even hardly feel the blower cups in there because you got a whole line of hair.
Especially if they smoke.
No, this is dog hair, cat
Talking about
hair.
the black dust. They be on the blower wheel.
No, that's different from what I'm talking about. So when you get dog hair on that blower wheel, it mats the blower wheel. So you literally can reach your hand in there and grab and pull literally a whole handful of dog hair off the blower wheel. And then you show them this is on your blower wheel. If this is on your blower wheel, what do you think's on your evaporator coil? Because it's blowing all this right up to your evaporator coil. Your evaporator coil is going to be matted with dirt as well. Which again, I'm going to tell you to open your eyes because one thing leads to another thing, leads to another thing, leads to another thing. So here we are, we're checking a blower wheel. Now what do we need to go check? And you're doing a heater check. And I asked you to run your fingers through the blower wheel, and you run your fingers through the blower wheel. Now, blower wheel, I'm asking you if it's dirty and filthy. So you can reach your phone in there and take a picture of it and see how dirty it is, bring it over to the customer, show them how dirty it is, and then charge them a couple $100, pull the blower wheel out, clean and put it back in. I'm gonna give you something else. If that blower wheel is really dirty, I'm gonna tell you how to clean a blower wheel because there is a specific way you really and truly need to clean a blower wheel. If you pull that blower wheel out and it's caked with listen to me, dust and dirt, and it basically creates a mud on that blower wheel itself. So I pull the blower motor out, because that's the only way you're gonna clean it. I pull the whole assembly out, and then I pull the blower motor off the shaft and everything. So all I have left is the housing and the blower wheel itself. If there's a circuit board attached to the blower motor and all that kind of stuff on the cabinet and everything, unscrew all that stuff and leave it there. And all you want to have left over is the housing and the blower wheel itself. Go outside, take your hose, and put your hose down, and then start spinning the blower wheel and shoot the hose in the cup. And just keep shooting the water in and keep turning the blower wheel as you're shooting the cup. So what you're doing is you're shooting onto the cup and releasing a lot of that dirt. But as you're doing it, it's filling up with water at the bottom of that housing, which is fine. Because as you keep spinning it, all you're doing is just soaking it in the water as you continue to get all the dirt off of each cup. After you do that, the next thing that you want to do is you want to empty all the dirt of it out, and then you want to now kind of turn your blower wheel to where it empties out, and then go spin your blower wheel again. And that, therefore, as you're shooting it, you're spinning the blower wheel and you're hitting every cup on it. You're getting all the dirt off of it. Next thing you want to do is you want to empty all that out, and you want to spray some water and fill it up at the bottom of that blower housing, and then you want to grab your chemical, your condenser coil cleaner, and you want to pour a little bit of condenser coil cleaner in the bottom of that housing that's holding the water now that you just sprayed in there. So it's only this much water, right? And then you take that blower wheel and you spin it up inside of that water that's got the condenser coil cleaner on it. And as you spin it in there, it's going to start eating all the dirt off of that blower wheel now. Then you take it again and you hit it with the hose again, and now all the dirt is literally going to come off that blower wheel and make it look almost brand new sometimes. Okay? Now, if you leave a little bit of dirt on one of those cups or two of those cups in the same area, when you put it back in, that blower wheel is gonna go. And the reason it's doing that is because it's imbalanced. Now you gotta pull it back out again, bring it back outside, find that little bit of dirt that you seen there, but you didn't think it was gonna cause a problem. And I'm telling you this because it's happened to me. No way I thought that little bit of dirt that I left on there was gonna cause a problem. Sure enough, unless that blower wheel's clean and balanced, it is gonna rock and roll, okay? Had to pull it back out, clean it again, get that little bit of dirt off of it, put it right back in, boom, spun perfectly after that. Now, with it caked with dirt, it wasn't noisy. When I put it back in with that little bit of dirt, it was rocking and rolling, okay? Why wasn't it rocking and rolling with all the dirt on it?
Because it was evenly
It
balanced.
was evenly balanced. There you go. Okay? So that is a big deal, guys. When you clean that blower wheel, you got to make sure all the dirt is off of it. Now, with the chemical that you poured in the housing of the blower compartment as well, swoosh that all around in that whole cabinet up inside there to where you're getting it all over. Now remember, that's condenser coil cleaner. You get it on your cuts and things of that sort. Do not get it in your eyes. Okay? Eye protection. Even if you have glove protection, whatever for your hands. I mean, you can wash it all off and all that kind of stuff. But swoosh it all around up in that blower cabinet, and therefore now you hose the whole blower compartment out, the blower wheel, get all the dirt completely out of the system, take all the dust and particles and everything, dog hair and all that kind of shit off the blower motor itself. Then you put the blower motor back on, and you have to take the blower wheel when you put it on, because the strap on the motor can't be. So here's your motor and your shaft, okay? So you may have a band for that motor that has dog legs on it like this, okay? And they go 3 around. Well, these dog legs here, if this band is down here or up here, it's pushing the motor in or pushing the motor out. So you want to know where it was when you put it in, and then when you have your housing, if you're looking at the housing from the middle, it basically does this. So that's the housing, okay? And then your blower wheel sets inside here. All right. So as you put this blower motor on, when you put this band on it, the band is going to mount to the outside so that your motor sits here and your shaft is through here. And now that band is here and your legs come out and screw to here. So depending upon how you end up pushing that motor in and out will also determine, do you have to push it out a little bit because you're too far in, which is going to cause the motor to be all the way over here, the blower wheel to be all the way on that side. So you got to watch where you put the band. Sometimes you actually have to take the band and put it closer to here to pull the motor out this way in order for the shaft to hit, right in there. You got to play with that a little bit. You got to watch when you pull it out where it was set at before and put it pretty much in the same spot. On the motor itself, a lot of times you're putting a new one in and you got screws on the outside of the motor here and on the outside over here. And that's 4 different things. You have to break these screws off because now those screws stick in here and may hit your blower wheel. Break them off. Just take a pair of alignment pliers and wiggle them and break them off. Okay? Now the blower motor, when you put it in, all this came stem from a blower wheel, didn't it? I'm gonna change my name to Mr. Rant. When you put the blower motor in, there are 4 wires right out here. I'm gonna call them yellow and brown and orange and blue. I don't know, they could be any other color, okay? Well, these 2 are connected and these 2 are connected. When you put the new blower motor in, if the blower motor is spinning clockwise, CW, clockwise, and as it turns, So if you look a side view of this blower compartment, the side view would look like this. And there's your blower wheel. So therefore the direction of your blower motor would be this. Okay? And airflow blows up. If your blower motor spins in the opposite direction, it will not blow your air up. It'll kind of blow it all over the place, and some of it will go up, and it'll be noisy. Turn it, and all you got to do to reverse the blower lead on this thing to where it goes counterclockwise instead of clockwise now, is you want to take, let's just say one's a male, one's a female, one's a male, one's a female. Take the female from here and bring it to the male on this one, and they're just going to swap partners. They're swingers. I don't know. Okay. You got swingers with blower motors. Where'd I come up with that? I don't know.
What's the next book you gonna put out? A Playboy?
It might be, man. I don't know. You know, this is the penthouse version, and we're in the swinger section here.
I just have to take your word for it.
I get you. All right, so now we have went over blower wheels, blower motors, thermostats, right? And then most of the stuff I asked you to go check on here was not the stuff that I went over, right? So again, the highlighted section on your left-hand side to say blower wheel does not just mean go check how dirty it is.
Everything associated.
Don't you have to check the rotation of the blower wheel?
Yeah.
Do I have rotation on there? No, I don't. Do I have capacitor on blower motor? No, I don't. Do I have program on thermostat? No, I don't.
Okay. Each line indicates that we should check every aspect of that line. Not
Yeah,
just what's
that's why
specific.
I'm giving you the video that says blower wheel does not just mean is it dirty. It means is the rotation correct. It means is it installed properly? Is it dirty? Is it filthy? All these different things. Is it noisy? Is the blower, is the hub broken? Is it making a lot of noise? Yep, hub's broken. Well, if I had a checklist to give all the things for blower motors and thermostats, well then I'd have one sheet for a thermostat, one sheet for a blower motor for you to go check all these different things, right? Well, that's what this video is for. So that as I'm explaining this to you, you're going, okay, he does want me to go check more of this stuff, okay? So on number 16 where I have blower wheel, I have inspect the blower wheel, important, take a picture and upload pictures of it. I have clean, let the picture show it's clean. Dirty, restricted airflow causes stress on the motor, give price to pull and clean. Filthy, restricts airflow, causes stress on the motor, give price to pull and clean. Minimum, must be cleaned and noted that the system will not work properly, that will not heat or cool. I missed the E in there. Heat or cool properly and clean. Okay, well I just went over number 16, which is basically telling you, go check to see if it's dirty. But in the video here, I just went over a whole bunch of other shit that's not in here, is it?
Right.
Okay. Blower cabinet, guys. What are you looking for in the blower cabinet? Same damn thing as the blower wheel, right?
Yeah.
You're looking to see if it's dirty, right? You're looking to see if it's got mold in it. So blower cabinet says clean, dirty, and filthy. Can you have a clean blower wheel and a filthy cabinet?
Yeah.
Yeah, because I could have cleaned the blower wheel last time and I can't do anything about the cabinet, right? So what am I going to do about the cabinet? The cabinet's filthy dirty, it's nasty, it's filthy, it's full of mold and mildew. What am I going to do about it?
Recommend one of those UV lights.
Recommend a UV light. What kind is it called? You remember? Ultravation.
The one for the cabinet, I don't know.
Yep, it's called an ultravation, one for the cabinet. Or they have one from Lennox that has 2 UV lights in it, one that you would put in the air handler itself and one in the supply plenum. Why am I putting blower cabinet in here? That's not a mechanical part. Why do I want you to check the cabinet? Again,
Filtration and indoor air quality.
for indoor air quality. Because I am trying to give you something to trigger in your head. I want you to go now, go check this. So when you hit pour, now you go over with the customer everything that you check pour. or filthy or dirty, right? If you check okay on it, you don't have to go over it with them. But I check poor or filthy or dirty on it, and then I go, this is for me to say your blower cabinet is filthy dirty. So here's a picture of your blower cabinet, ma'am, and it's full of mold all up inside there. Your blower wheel is getting like that too, because if your cabinet's like that, your blower wheel is going to be like that, unless somebody replaced your blower wheel or cleaned it. So what I'm going to recommend doing with all the mold and mildew, as you see in this picture, the mildew forming all inside of your air handler cabinet. My recommendation to you on that is we can install an ultraviolet UV light. That UV light shines inside that air handler and kills all the mold, spores, bacteria, borne contaminants, viruses in that duct system or in that cabinet. So by putting that UV light in there, all this mold growth that you have in here right now, it's going to start killing all that, because the UV rays are going to affect it and start killing it, destroying it. And it's going to help prevent more mold growth from there on out. Okay? So I put cabinet in there to do what?
So
Trigger indoor air quality to put a UV light inside the air handler. Okay? Which brings me over to the next one, which is going to be your filter. So I'm asking you to put the size of it and clean or dirty. Why am I asking you to put the size on it? Because up at the top right hand corner, I'm asking you to put the model number of the system, which tells me the tonnage of the system, which if you put the filter size tells me what?
the tonnage.
If you put the filter size tells me what, Gage?
CFM.
CFM. Height ton, width ton 2 equals your return CFM. So if you got an RH1P 4821 STANJ8 air handler, what tonnage do you have? 4 ton, 48. And I have a 20 by 20 filter. How many CFMs do I have on my filter?
It's 800. That's a 2-ton.
So you're telling me I got one 2-ton, 120 by 20 filter on a 4-ton air handler.
You gotta resize your return.
Or you gotta add another one to it.
Mm-hmm.
Another 20 by 20 and give you the full 1600, right?
Yeah.
That's why I'm asking you to put the filter size, because I'm asking you to have it register in your head, height ton, width ton 2. Remember, these checklists are not checklists, they're triggers. Trigger something in your head to talk to the customer about. Everything is a trigger. They're my triggers. So I invented the invoice. And I invented the invoice as a trigger for me to go, I know when I go check the blower motor, I'm going to check the capacitor. It's just, it's obvious, okay? I'm going to check the capacitor, but it wasn't obvious to you, but it is on the condenser because I actually have it on the checklist, okay? So here, filter size tells me what? I want to know what CFM it is. And is it clean or dirty? Okay, meaning did you change the filter before I got here? Okay. Next one. Why do I have filtration? I just had filter on there. Why do I have filtration now?
Indoor air quality issues.
So what is the difference between a filter, meaning filter grill, and filtration?
Filter protects your equipment, doesn't really filter your air.
Perfect answer. Did you watch a video or anything?
I know you said it before.
Yeah. You're right. I think it was yesterday. All right. So the filter that you have for your home, ma'am, that is there not to clean the air in your house. It's there to keep the dirt off of your air handler and blower motor and stuff. A filtration system consists of, I'm going to give you my best one, which is a MERV 16 filter, because your filters are actually rated in MERV ratings. The higher the number on the filter, MERV 16 is the highest I have that I know. It may be more than that. That filter catches down to 0.3 microns of dust particles, pet dander, pollen, mold spores, and bacteria. Bacteria can be maybe 1 micron, and the filter itself catches down to 0.3 microns. Now, every filter is different. Pass me that filter right there. Every filter is different. This particular filter is a 4-inch pleated filter, as you can see. and it is 19 3/4 by 22 7/8 by 4 7/8. It's a MERV 11 filter. The one down at the bottom there, give me that one now. Okay, now this is a MERV 11 filter, and I'm gonna see if there's a rating on here. And it's got an arrow on this filter that tells you the airflow goes that way. So this one is a MERV 16 filter, okay? And this one is a MERV 16 filter on it. So this is your Healthy Climate filter, MERV 16. The product number on it is a Y6605. It's 16 by 26 by 5. Now, which one of these filters, and I want you to see how big the accordions are in this one, and then how small the accordions are in this one, how many there are. So look at how many there are comparative wise. This one doesn't have half the amount of accordions that this one does, am I right?
Right.
So if I stretch this filter out, take it out of the box, I'm just gonna make an argument and say it's, I don't know, 6, 7 feet long, okay? If I take this one out the box and I stretch it out, it's 25 feet long. Which one has a better filtration?
That one, because it's more surface area to catch stuff.
More
coming
surface
in.
area. Which one do you think actually restricts the airflow more? All these damn pleats in here or less pleats?
I would think the black one with the more.
This one actually restricts airflow more than this one does.
Why?
Because you have more surface area for the filter. As you start clogging this filter up, it restricts airflow.
Yeah.
Plus, this is a MERV 16 filter. This is a MERV 11 filter. This is a MERV 16. Now think about this. If it's MERV 16, that means it's catching finer particles. Well, that means it's going to clog up faster than a MERV 11 because this one gets more dirt by it. Right?
No.
Well, then you would go,
You got more surface area here. So if you got more surface area, that's less chance. So it'll clog up. You get my point.
yep, this one's going to clog up less.
Yes. Yeah.
Not as fast as this one because I have, call this one 6 feet and this one 25 feet, okay? Well, I got 4 times the surface area of filtration on this one than I do this one, okay? So if I have a 20 by 20 filter here that's a MERV 11 that's 1 inch thick, not 4 inch thick, it's 1 inch thick, is it filtering your air for breathing? Or is it just trying to keep your equipment clean?
That's keeping your equipment clean.
What does a customer normally think?
That is doing the air for them. That is
It's cleaning the air in their
still.
house, filtering the air in their house. Now, filtration to filter. If I go buy an electrostatic, washable, real thick ass freaking filter from Home Depot that when you pick it up is almost like a sponge, it's hard, it's thick, and it's an allergy free filter. Here's what you got to understand about filters. Filters have a resistance to them of airflow. So if I have a blower motor that's running at high speed and I put this filter in it, it has a resistance to it. And I was looking to see if it actually had what the resistance was on it on the tag, but it does not. So a lot of times on it, it'll actually give you the resistance on it, but it does not. Okay, let's see if this one does. So it'll give you a pressure drop sometimes, and I don't even see it on this one here, of what the pressure drop is on this particular filter. I know in Healthy Climate on their website you can look it up to see what the actual what the resistance is on that filter. But every filter has a pressure drop on it. The worse the filter, meaning how thick the filter is, how much does it restrict your airflow, will give you a bigger pressure drop on that filter. Okay? The more pressure drop you have, the more restriction of airflow you have, the less airflow you actually have going across your coil. The colder your coil gets, the less airflow you have coming out of your entire system, the less capacity, BTU capacity you have on your system. Okay? Therefore, when I say filtration as opposed to filter, I'm just asking what your filter size is on filter. Because I'm asking you to go height time, width time 2, and what CFM is it? That's what I'm asking you to do there. When I say filtration, I'm asking you, do you have a secondary filtration system in that house? Most of them, the answer is no, I do not.
So you usually use both? You usually use like the little filter for the equipment and the filtration for the filtration?
Yeah. Catch the big stuff with the first filter. In my house, I got a filter on my wall, and I got a MERV 16 filter in the attic. I don't have to change that MERV 16 filter, but maybe once a year.
Just keep up with your filter for your equipment, correct?
Yeah. Now, if you go inside my blower compartment, it looks like it was installed yesterday. My blower has nothing on it, man. It's clean as can be. I'm going to give you a quick story on the MERV 16 filter, which is phenomenal. Absolutely phenomenal. So the PCO filtration system, okay? PCO filtration system is sold by Lennox. It's called the Pure Air system.
Like the one with the heat pump yesterday, they got one.
Yeah,
Yeah.
exactly. They
In
do.
both units.
Yep. So that has a MERV 16 filter, UV light, and a catalyst. I went to this lady's house years and years ago, probably 15 years ago, and she's got 36 cats and 7 dogs in her house. Yeah. Can imagine what the house smells like, especially when the air conditioning's off. Okay, that bad. So many years ago, we changed her air conditioning system out. Really nice lady, but just to me, has a problem.
Cat lady.
Yeah, big time. And cat and dog lady. Well, her house smells like cat shit, dog shit, cat urine, dog urine, and everything else. And it smells like that because it's everywhere in the house because she don't clean her house either. Okay? So the house is just nasty. So the first time I went over there, all her blower wheels completely dirty, unit's old. I ended up selling her a new unit, and it's vertical in a closet in the middle of the house, kind of. So I told her, I says, look, ma'am, in order to replace your unit, I literally have got to put in a filtration system in order to clean the air that's running through here so I don't destroy your furnace or your blower motor inside of here. And also, I was thinking for her as well, I could have just put a HC16 filter in, which is just a filter. I was also thinking about her health. So I wanted to put a PCO in because I wanted to kill all that pet dander and the odors and the ammonia smell and stuff like that in the house. It was just nasty, okay? So I put a PCO filtration system in that has the UV lights and the catalyst with the MERV 16 filter. Fast forward the story, I don't know, 6, 7, 8, 10 years, whatever it was. Go back out there, and her blower motor inside was not running. So I walk over to the system on the inside. Now she has filters that she changes on the outside as well as the PCO. Because it's vertical, it sits on the cabinet. So as soon as the airflow comes through that filter, it hits another filter, right? I mean, within this distance. I knew when I pulled that door off of that furnace, it's a gas furnace. I knew when I pulled that door off of that gas furnace that the blower wheel was just going to be caked with dog hair and cat hair and pet dander and just nastiness. Because I've seen it so many times in so many houses. As a testament to that PCO filtration system, I wish I would have had it all on video. Because when I pulled the door off, I am telling you that blower cabinet was just as clean as can be. There was no dog hair, no pet dander, no mold all over the blower wheel, when you pull the door off, you got dust and dirt all inside the wires and all that kind of crap inside there. I am telling you, her blower compartment was just as clean as could be. And I was totally freaking amazed that how good of a job that MERV 16 filter did with the UV lights and the catalyst to keep her blower compartment just as clean as could be. I'm gonna give you one more story on that PCO filtration system that I am telling you, if I would have had a camera, and this is a literal true story, and it happened probably 20 years ago, okay? I went out to a lady's house. Her little girl, 6 years old, literally almost died about 6 weeks prior to me ever going out to the house. Real bad allergies and just had medical issues, 6 years old, with breathing and stuff, okay? So when I went out there, they were asking me about indoor air quality in the house. So I went and checked the air conditioning, the whole 9 yards of everything. In their house, literally had too big of an air conditioning system in it. The ductwork was leaking, all that kind of good stuff. So my recommendation was, let's replace all of the ductwork in the house to get rid of all that mold and mildew and crap like that. I'm gonna put a new supply plenum in, and we're gonna put a UV light inside the supply plenum that's gonna help kill mold spores and all that kind of stuff in the duct system, right? All new ductwork, strap it all up. I didn't change the air conditioning system, same exact air conditioning system. I put a dehumidifier in the house as well, because I want to lower the humidity level in the house, which also kills dust mites. When you have a lower humidity in the house, 50% relative humidity, all of the viruses and bacteria and things of that sort, the allergens in the house do not, multiply as much. So we put all that stuff in her house, and it was no more than 3, 4, 5 days later. Went over to the little restaurant right over here in Manhattan. Me and my wife went over there for lunch. Walked in the door, and there was the little girl with her mom and dad. And she was there, and so I, just waved to him, told him hi. This little 6-year-old girl, and I swear to God, I wish I had this on camera because it was just heartfelt. She came over to me, she says, "Mr. Taylor," she says, "I want to thank you for making my house so I can breathe." Dude, that like to kill me. That is a true story. True story. That PCO filtration system, guys, I have seen it do some serious freaking wonders in houses. At cleaning the air in the house, because remember, your first filter cleans the equipment, keeps the equipment clean. MERV 16 filter filters the air and cleans the air. The UV lights destroy the viruses and bacteria, airborne contaminants. The catalysts and the UV lights interact together and destroy all the VOCs. So the time you get the airflow through that system, you have clean, healthy air running through that system. Then I put a UV light inside the supply plenum to kill any mold spores in the supply plenum as well. I lowered the humidity level in the house in order to stop all the bacteria growth and mold growth. Totally changed the way that house went. Totally changed the way that house went. So, filtration is different than a filter. And that's why I have filtration in there. What is the other reason I have filtration in there? Because I'm telling you, hey, they don't have any filtration because you checked none. Okay, fair, poor. Or you checked poor. Well, I got a good filter right here. How are you telling me my filtration is poor? Because that's not filtration. It's a filter. It's not filtration. Get me now? Okay. IAQ, indoor air quality, is your next step. Indoor air quality is okay, fair, and poor. So all the things that I just went over between your filters and everything. Yeah, Basin, taping. Hurry up. Hurry up. Possibly do. I don't know. Yeah, probably. I'll say. Just wait for me to finish. Which you could have waited anyway instead of calling me. So indoor air quality, with all the other things that we just went over, blower wheel, blower motor, filter, filtration system, and now indoor air quality. What am I trying to hammer into your head, guys?
Indoor air quality, giving every step to what they need, what can help them.
Give them options, man. If you never knew about a Remy Halo, You never knew you could put a UV light inside your air handler. If you never knew that your supply plenum, because that's one of the things that we're going to check, if you never knew the supply plenum was full of mold, and I put indoor air quality as poor, but I don't explain it to you, then what am I really doing?
Just marking a line, pencil whip.
Marking a line. I just pencil whipping the paper. So again, indoor air quality is to give you an avenue to go talk to the customer about indoor air quality in their home. And you brought them a picture of the blower wheel. You brought them a picture of the dirty air handler cabinet. You brought them a picture of the supply plenum that's full of mold and everything in their system. And now you give them an opportunity to remove all that stuff from their home and clean it and put a UV light in to destroy all that stuff and keep it clean. Did you do the customer the right job, or did you lie to them, cheat them, and steal? You did the right job. Okay? So don't pencil whip your paperwork. There's a check there for a reason, and the check is telling you to go look at something and talk to the customer about something. There's a guy over there in Woodmere. He literally has to have what you call a clean house because his son has got some type of autoimmune disease. And his duct system was just a disaster over there. So we went over there and we replaced all the ductwork in this system and put in UV lights and filtration systems and all that kind of stuff. But, you know, that's a total medical issue right there. And he was even asking, what else can I do? You know, dehumidification. I got to keep the humidity level at 45, 50% relative humidity in my house. Well, you got a single stage air conditioning system. You can't, unless you put a dehumidifier in. He had to do all this stuff for his son, you know? All right, your last one is UV lights. Okay, none broke and blown. Okay, now I went, do you literally have a UV light? None. So what am I telling you? Look, ma'am, your filtration is poor. Okay, your blower wheel's dirty, your blower cabinet is dirty, and you have no UV lights in your system. I am giving you every opportunity in the world to talk about filtration, REMI halos, indoor air quality, and ask you, does it mean anything to you? It may not. You may not give a shit about all this stuff. But I brought you pictures, didn't I? I uploaded the pictures in my documentation, and I put a recommendation in there. Recommendation, install REMI halo or PCO filtration system for better indoor air quality. Okay, all you can tell me is no. Yeah, I've never been bit before. Okay, so that's all my airflow, blower compartment, all that kind of stuff, which is at the bottom of the invoice here. So it just took us an hour basically to go over these 6 or 7 or 8 steps right here, down at the bottom. And the entire bottom of this invoice is indoor air quality pretty much. Okay? So now we're gonna go up to the top right here, which basically has dry bulb supply and dry bulb return. Dry bulb supply, dry bulb return, you get those two and you subtract the two from each other and it's called now your delta T. Your dry bulb return means what temperature is it in the house? 72. Dry bulb supply means what temperature is it coming out of your vent? 52. Subtract the two, you get 20 degrees. I have 20 degree delta T. You turn your heater on, 70 degrees in the house. I have 115 coming out of my supply vent. Subtract 115 from 70 degrees, you get 45 degrees. I have a 45 degree delta T. Now, I'm asking you for your supply temperature and your return temperature. You could easily now take that number because you actually have to figure it out, don't you? Of what your delta T is. You got to figure out what that is. Well, down here at other, you can just put delta T down at the bottom here. You can just write on there delta T 45. Or in your work performance over here, check the airflow 45 delta T. Okay? Write it down. Make it easy. Let the customer see it. Let me see it without having to figure it out. Even though it's easy to do, your subtraction and everything, but just write it down, man. Okay. Your next one is your coil, R22 or 410A. Does that have anything to do with an electric heat system? Or a gas furnace?
Yes.
Why?
Airflow restriction.
So the line item says coil. R22 or 410A has nothing to do with my gas furnace.
I thought you just meant like the coil itself. Like,
No, it has nothing to do with R22 or 410A. It's literally just on there for air conditioning because I never changed the right side of my paperwork. Now, I'm going to tell you what it does signal for me. When you write on there R22, how old is the unit? Does it need to be replaced? There you go. Now, ma'am, the blower motor's dirty. Okay? This is dirty, that's dirty, your capacitor's weak, your plenum's falling apart, and you have an R22 system. What does that tell you now?
We should immediately advise that an upgrade.
See, it's just one more thing. It's just one more thing that you have checked on your system to remind you. These are reminders for you. You did the whole check on the system. You checked it all down, and then you write your work performed, check the operation of the system. Found is your next deal. Or most of the time, I start off work performed. I started off with found. And then everything that I have other than okay, found. Capacitor weak, blower wheel dirty, cabinet dirty, no UV light, filtration is poor, or no filtration, drain line runs uphill, whatever. I found all this stuff. I can stop there. Since I found it all, I'm not writing my invoice at this point in time and then finishing my job because I found it. What am I supposed to do now? Go to the customer and say, ma'am, I found all this stuff. Here is a price to repair it all. Do you want to repair all of it? None of it, some of it. Go ahead and repair all of it. Take all of it. $1,200, no problem. Repair it all. So then I wrote found, and I wrote all the things that I found. And the customer said, go ahead, put the capacitor on, clean the blower wheel, change the fan motor on the outside, fix the plenum, fix the ductwork, do all of it. I want everything that you told me to do. Install the UV light, install the float switch, put a surge protector on, everything you told me that you found. So then on my repairs, I'm going to have a repair number for everything with everything that I did with a price on it. What am I now going to have recommendations for? Nothing. They just did everything you told them to do. Okay? So what I'm saying is don't go put all the recommendations before you ask them to do the work. That's what I'm trying to get across to you. Make sense? Yeah, you just wrote a whole bunch of stuff for nothing and they want you to do it. Yeah, you gotta write recommendations now, except the things that they didn't want to do. Now you wrote the recommendations because they wanted to do 2 out of the 6 recommendations that you made for them of stuff that you found. Then you put recommendations on the 4 things that they don't want to have done at this point in time. And now you also add that diagnostic, that trip charge back in there so that if now they call back and want to fix the collars for $50, no, it's $155 now. Because I have to go back out there to go do it. So I'm not going back out there for $50. It cost me more than that to send my truck out there. See where I'm at? So then after all your recommendations, you actually have to put plus trip charge 105. Or just add it into the one that you definitely have to have. It's a capacitor that's almost blown. And you put number 1. And put a number 1 by it, because it's most important, number 1. Replace capacitor. If the capacitor costs $200 normal price, make it $305. Because when they call back for it, it's built in there. If they wanted to replace it right now, it's $200. If you want to replace it in 3 months and call me back, I gotta charge $105 to come back out, plus the capacitor. Okay. All right. The next one on there is air leaks, huh? None, small, and major. So you're by the air handler, checking your air handler out. You're checking your heat strip out. You're checking your gas furnace out. You got a vertical system, horizontal system, downflow system. Can't you run your hands around everything? See if you feel air loss around it. Okay, are you blowing air all over the place? Can you get some silicone or painter's caulk or whatever and fill up those gaps and stop all the air leakage? There you go. Alright, your coil. Is it clean, dirty, or clogged? Alright. So your coil, if it's clean, dirty, or clogged, that just went back into all the other stuff in your blower wheel and your blower compartment, all that kind of stuff. Check the coil, especially on a vertical system where it's easy to check. Take a picture of it if you can. Look to see if the coil is dirty. Horizontal, you may be able to cut a hole on the return or lift the corner of the return plenum and look into the coil from the return section. If it's clogged, this would change your delta T and restrict a lot of airflow. Excuse me. If your coil's dirty and you pull it out and clean it, will you probably have to adjust your charge?
Absolutely.
Hey,
You might want to recommend acid washing the condenser as well.
you always want to recommend acid washing the condenser as well. Because what good does it do cleaning your evaporator coil if you don't clean your condenser?
Nothing. Your charge will be off.
What good does it do recommending cleaning your evaporator coil if you don't pull and clean your blower wheel?
Nothing.
So guys, if you're pulling a blower wheel out to clean it, and it's a gas heat system, what's the chances of your evaporator coil being dirty?
Good.
Pretty damn good. Now, how can you check the blower? How can you check the coil to see if it's dirty on a vertical gas heat system? I'm going to give you 2 ways. Can y'all give me some ways? I'm going to give you 3 ways.
Use like a snake camera, right?
How you stick a snake camera in there?
Use like through the burners or something like that.
No, you take the limit switch out, which has a little hole this big. You stick a snake camera up in there and you're looking at the evaporator coil. Because it's in the blower section of it, right? It's in the stream of it. So you just pull 2 screws, pull your limit switch off, stick your camera in there and look at the coil. And then you can take a picture of the coil with your camera and upload it to your phone if it's Wi-Fi. How else can you tell if your coil's dirty and you can't get to it? How about static pressure?
That's true.
Okay, check your static pressure. Return, pop a hole in your supply plenum, see what your static pressure
Did
is.
that yesterday.
There you go. There you go. Great job. I'm going to give you another way. You don't have anything to measure static pressure and you don't have a camera. I literally can take the blower wheel completely out. Take the whole thing completely out. And get my little ass right up inside that heater and take a flashlight and I can literally see right through the chambers all the way to the coil. I've done that a bunch of times. And clean the coils. Okay? By seeing it like that. There's a bunch of ways you can check the coil. See if it's dirty. Okay? Alright, refrigerant leaks. Well, you're checking a heating system. Are you really and truly checking for refrigerant leaks?
You might have a heat pump.
You might have a heat pump. What about refrigerant leaks, guys? What have I told you about going check a heating system and then while you're there,
Still cutting the AC on, putting your gauges on the system.
yeah, because it's like if you go to a heater check today, it's 85 outside.
Yeah.
And then you look at how the system just looks. What's the condition of it? How old is it? Is it R22? Is it 410A? Is it 2 years old? Is it 15 years old? It doesn't look like it's in good condition. They call me out for a heater check. You know what I'm going to do? For free. I'm going to walk in there with my gauges and I'm going to check your condenser pressures and everything like that and superheat and subcool and all that kind of stuff. You know why I'm going to do that for free, guys? How do I make money?
Recommendations.
Finding things. Okay? I've told this story 1,000 times and I want you to tell it to yourself 1,000 times. If you go in business for yourself today, you have no advertisement out. You may not have enough money for mortgage bills, rent, car notes, everything like that come the end of the month. But I'm in business today and I go, I'm going to do this thing. And nobody calls me today. I am getting a little bit nervous. about making rent and all that kind of crap at the end of the month. Day 2 goes by. I get a couple phone calls, but they were just asking me how a thermostat works. And you go, damn, well, I can go out there and show you how the thermostat works. It's $105. No, I just need to know how the thermostat works. Okay. Finally, you get a service call. Air conditioner's not cooling. Heater's not coming on, whatever it is. You go out there. I bet you will spend as much time as you possibly can going over the entire system to try to find something, as long as you have morals that you're not going to make crap up and try to sell to a customer, to try to screw the customer, to try to make money, because rent's due like literally tomorrow, and if I don't get $500 out of this customer, I can't pay rent tomorrow. So let me just go tell them the capacitor's bad and the contactor's weak and the coil's dirty and this is dirty, and see if I can get $2,000 out of them. And you go do that, and they go, okay, if that's what needs to be done, I have to call my son and get him to send me some money over. And you just went and screwed a little old lady because you need to make rent.
You shouldn't sleep that night.
Man, you shouldn't sleep at night. You ain't got to do things wrong like that, guys. No, you just don't in this business. I can literally go to whoever it is, and I don't care how old you are, how young you are, what background you have, I don't care where you live at. My job is just to go check your air conditioning system and give you as many opportunities to enhance your system or make it work to 100% efficiency as possible, as much as I can. And I go check your system and I find your capacitor is weak. Well, if I take a picture of it and it's reading 33 microfarads and you got a 45 microfarad capacitor, can anybody prove me wrong?
No.
No, I took a picture of, I got my capacitor, I got my meter in it, and it's, if you look at the capacitor, it says 45, but I'm reading 32. But the condenser's still running. And if she goes, no, I don't think I want to replace it. So she calls Cousin Bill, and Cousin Bill says, ain't nothing wrong with that capacitor. It wouldn't be running if it was blowing. Well, Cousin Bill don't know what the hell he's talking about. Okay? So he don't know what microfarads are. Okay? He don't know how to test a microfarad, but he's telling you, unless it blows, it's still good. You can go out to that house, any house, and you can look at everything you possibly can. Take pictures of the duct system, the mold, the mildew, and all that kind of stuff. Bring it to the customer and give them the opportunity to enhance their home. They may say yes, they may say no, but don't lie. Don't cheat them and don't steal from them. Just do everything you're supposed to do and let them make the decision what they want to do for their own home. And then you got that little old lady. And I've run across a whole bunch of little old ladies, and they are literally waiting for you to tell them what they need to do. So I also take a step further in this, and I may be looking to pay my rent at the end of the month, okay? But I'm also going to tell them like this. All these extra things, recommendations that I am telling her that she could have done to enhance, in this case, because it was just a clogged drain line, I'm just going to say, okay? I'm giving her these extra things to enhance the performance of the system. And then she tells me, she says, okay, but is it working right now? Am I gonna have air right now? And I go, yes ma'am, you're gonna have air. Well, as soon as I can save up some money, I will call you back and get these other things done. Now, I'm making all this up here for a second because this one I would not do that with. If I go to, a 45-year-old man's house, lady's house, am I going to give her opportunities to enhance all that kind of stuff? Yes, I will. And she's 80 years old, and I see her units 12 years old, 15 years old, and her clogged drain line and all that kind of stuff. Am I going to take pictures of her supply plenum and all that kind of stuff? If her blower wheel's dirty, and her blower motor, her coil is dirty, and my pressures show that it's going to freeze up on it, am I going to tell her? Absolutely, I'm going to tell her. But am I going to sell her a hard start kit to sell a hard start kit? Am I going to sell a time delay just to sell a time delay to put a time delay on the system? No, I'm not. I'm not. That little old lady is looking for me to get her air conditioning system running, and hopefully you don't lie to her. You know, that's what she's waiting for. And in that particular case, you make sure that that system, when you leave, is going to continue to run, and it's going to work efficiently. But if the condenser's dirty, you still got to charge her to clean the condenser. If the blower wheel's dirty, you still got to charge her to pull the blower wheel out. If the evaporator coil is dirty, you still have to charge her to pull the evaporator coil out. It's not your fault it's all dirty. And you still now have to give her a price, because the only way you're going to get the old lady really cooling is do all that stuff. Now you're doing the right job for her. Yes, I had to pull your evaporator coil out and change your blower motor because it was bad, and I had to clean your condenser and add a little bit of refrigerant to it. Yes, I did charge you $2,000, but your system's working properly now. I had no choice. I had to do all those things. Okay? I've always told people when they're starting off and they start learning a little bit about air conditioning, if my mom and dad lived in Arkansas, so I can't go fix their air conditioning today if it breaks, right? I can't just go drive to Arkansas today and go fix their air conditioning system. So we called Joe Blow's air conditioning. Joe Blow went out there and he found that the low voltage wire to the condenser was chewed up by the dog. So Joe Blow goes ahead and he just puts a wire nut on it, cuts back the wire, puts a wire nut on it, air conditioner's on it. Well, I do air conditioning, but I'm 8 hours away from mom and dad, and I go, hey Joe, what'd you find? Man, it's just a dog chewed the wire on the outside. Okay. I repaired the wire, everything's working fine. So okay. 2 days later, it's not cooling again. Well, Joe Blow's not answering his phone, so I called Tommy. Tommy goes over there and he checks the air conditioning system out. Dog chewed the wire again. So this time he takes the low voltage wire and he takes some copper off of his truck and he runs all the low voltage wire and copper all the way up to where you can't get to the low voltage anymore. The puppy can't get to it, right? So then Tommy says, well, let me put the gauges on the system and check everything, make sure everything's working properly before I leave. And then he sees the dog's been throwing dirt all over the condenser, laying by the condenser, and the condenser's filthy dirty. So Tommy's got to clean the condenser. So he puts gauges on the system, and mom's got a vertical air handler in the inside, so we're going to make this easy. So I walk in the inside after I put my gauges on and I get the system running, and I check the inside unit, the air handler condition, all that kind of stuff. I'm looking at my duct system. So what I'm going to do with my phone, I'm going to reach underneath there, I'm going to take a picture of the evaporator coil, and the evaporator coil is filthy dirty. So I have to charge them to clean the evaporator coil. So I tell Tommy when he goes out there, look, before you do a whole bunch of work, I need you to call me and let me know what's going on. Well, I know air conditioning, so I know if Tommy's going to know what he's doing or not. Tommy calls me up and he goes, man, check the air conditioning for your mom. Here's what I found. Dog chewed the wire again. So this time I went ahead and I just encased the copper, the low voltage wire in copper, and strapped it up to where the dog can't get to it anymore. So you shouldn't have that problem anymore. Great, thank you, I appreciate that. But look, the dog was also throwing dirt all over the condenser on the outside. I have a picture of it. I'm gonna send you the picture of it. So I had to clean the outdoor unit because my pressures were just all whacked out because of all the dog hair. All the dirt the dog's throwing all on it. No problem, clean the condenser. And look, while I was at it, I went ahead and inside, and your mom's got that vertical air handler inside. I took a picture of the evaporator coil and the blower motor, and the evaporator coil and the blower wheel is filthy dirty. I sent you the pictures. I have to pull the coil out, and I have to clean the coil, and I have to pull the blower wheel out and clean the blower wheel to make your mom's system work properly. Total price is going to be $1,000 to do everything that I'm telling you I need done. Which person do you want going to your mom's house? Joe Blow, who just went and repaired the wire, or Tommy, who went and looked at the entire system?
Tommy.
Okay? So if you want Tommy to go to your mom's house to go check her air conditioning because Tommy is going to be thorough, then what I'm telling you is don't be Joe Blow who goes out to that system and only checks one thing because the drain line's clogged up. You blow the drain line, you leave.
Still go put your gauges on the system.
Don't be Joe Blow. And that's your typical, I am telling you, that is your typical AC technician. He will fix bare minimum and look at bare minimum because he's never been trained to go look at the entire system. So when you want to be a good technician, then you're going to be a thorough technician. And you are tempted on a daily basis when it's hot as shit outside and it's 8 o'clock at night and you're hungry and you're ready to go home and you got one more call to go to and the drain line's clogged, you're tempted to go in there and go, float switch up, blow the drain line. All right, here's your service fee, charge your blow drain line, and I'll leave. And you turn the invoice in and it says, blue drain line. And I go, where's your head pressure, suction pressure? Man, it was like 8 o'clock at night. I said, so where's your head pressure and your suction pressure and your superheat and your subcool? You didn't put, I didn't put gauges on the system, man. It was like 8 o'clock at night. I got them air conditioned now. Well, I guess you need to go back for free now and go finish your job, huh? Oh, he said everything was working fine. I guess you need to go back for free, don't you? And go check this guy's air conditioning system like you were supposed to do. Don't be a jackleg, man. Just, I will tell you over and over and over and over till I'm freaking blue in the face. If you want to be a good technician, you need to follow all these checklists and not just look at what the checklist says, but look at everything the video is saying, okay? You need to go check for, okay? And then you need to memorize all those stuff. So when you look at blower motor, every time you see blower motor, here's what you picture in your head. A blower motor with a capacitor right next to it, all together, and you should go, yeah, I gotta go check the blower motor and capacitor, yeah. Don't everybody check the capacitor? Well, no, it just says blower motors. And it just says dirty. It doesn't say check the amperage. It doesn't say check the capacitor. It just says clean or dirty. No, it means check the capacitor, okay? So, refrigerant leaks. You're checking the heating system. You're not doing refrigerant leaks, are you? But if you go put your gauges on the system, or if you turn the air conditioning system on and you go outside, and let's say you let it run for 10 minutes and you go outside and you feel that suction line because you don't have the gauges like with you right that second, and that suction line does not feel cold, you need to go grab your gauges because there's something else wrong with that system. Now, that goes to your refrigerant leaks. Okay? What about when you run your air conditioner and when you get there you're going to do a heater check? Well, the air conditioner's running right now. I bet I can go shoot my return air real quick with a laser and my supply with a laser and get a delta T, and I can kind of tell you if you got a refrigerant leak sometimes, right? If your delta T's not right. How about if I ask the customer if it's been cooling fine in the middle of the day and everything like that? Yeah, it cools fine. No, it don't cool in the middle of the day. Again, when I get there, my laser's on my side or something. Shoot the return, shoot the supply before you turn your heater on. That tells you delta T, right? That should tell you whether your air conditioner's decent or something, right? Use these things, man. Use them. Use your head. Use your tools. Have a protocol, have a process that when you walk in a house, as soon as you walk in the house, I got a laser in one hand. Got a tool bag in the other. As soon as I walk in the house and I walk past the grill and she's walking me in and I go, beep. I shoot the temperature of the supply grill. As I'm walking in the house talking to her, I'm shooting the grill. What are you doing? That's just telling me temperature of the grill. 52. Shoot the wall. Boom, 72. 20-degree delta T. I know my air conditioning's okay. See how quick you can do this shit? But if you don't have the tools and you don't think about stuff like that, you're wasting your time. Right? Alright, coil pan. Hell, you're inside the air handler, you're checking your heat system. You can't check the coil pan too? See if it's clogged up? You can't check the coil? See if it's dirty? Sure you can. Okay? While the air handler, look inside for the coil, clean the debris from the pan. Okay, no problems, clogged, clean it and blow the drain line. Rusted, make sure water is not leaking through. TXV. again, I'm checking my heating system. Why do I have TXV on there? Could be a heat pump. Okay, if it's a heat pump, you're checking it. If it's a gas heat system, are you checking your TXV? No, you're not. How are you checking your TXV when you walk in the house? Return, supply, air conditioners working properly. Now I just checked my TXV, didn't I? Pretty much, to a point. I haven't put gauges on it to literally check my TXV, but there's just something that's just telling you these little things. Again, the right side of this invoice was not quote unquote made for heating. It was literally, I just left it there when I put the heating stuff on, okay? Next one is what? Turn the page on it. Piston, same thing. Check your TXV. I mean your Delta T, excuse me. Now we're getting into your duct system, your return plenum. Check to make sure that the return is the correct size. Flex duct is not used for return air chases. The air chase is restricted. Plenum is not falling apart or caving in. A lot of people put a lot of shit on top of your return plenum and they cave it all in. And if it's duct board and you put your hand on top of that return plenum and it sinks down, well, the duct board has separated from the exterior paper of that return plenum. You got to rebuild that return plenum properly in order to hold that top of it up. So we give them a price on rebuilding the whole return plenum in transition. OK is proper size. Restricted plenum is too small, attached with flex duct to it, to the unit. The chase is too small. Filter grill is too small. Leaking. Return not sealed. Run your hand under the return and transition. Feel for air leaks. Remove debris from sitting on top of the return, crushing the return. Silver tape, mesh tape, then mastic the seams. Charge for all of this unless we installed it within the last several years. So run your hand on your return underneath it and see if you got air leaks or if the tape. If you hear this sound, tell me what it is. What does that sound?
Leak on your return.
It's silver tape doing this in the wind. And it will drive you crazy in the middle of the night and everything's quiet in the house and all you hear is and the customer's going to call and go, it's making a squealing sound. I don't know what it is. I can't find it. I'm telling you what it's going to be. It's going to be silver tape. Okay? How do you fix that silver tape? Mesh tape and mastic. Because the silver tape has got unglued from the supply or return plenum is what's happened. And the air is passing through it and it's just vibrating. And it makes a loud sound. But like normally you just can't hear it, but in the middle of the night you're trying to sleep, you're hearing it. So when you hear that sound, I'm telling you, go look for silver tape. Bring mesh tape up there, and wherever the silver tape ends, you put mesh tape on it, and then you mastic it, and it won't come off. Okay. Supply plenum. Make sure that the supply plenum is the correct size, that the coil is not being blocked. Check for air leaks around the collar. Check the slope is back towards the coil or air handler, not leaning towards the end of the plenum. Is the plenum supported at the end of the plenum? With ductboard, is the entire plenum supported with straps? So if I got a horizontal unit and I got a ductboard supply plenum, which I do not ever like to do, I have to literally support the entire plenum because all I can do is tape the ductboard plenum on. Can't really strap it. The only way I can't screw it. The only way I strap is if I run a strap around the supply plenum and then hang it up. Okay, then it don't fall apart. Sealed. Everything is mastic sealed. Collars are sealed. S is underneath the coil and the plenum. All right. Leaking. Literally pass your hand around the supply plenum and feel for leaks. Falling apart should be obvious. It's been rigged, not supported, not sealed, wrong size, needs to be replaced. So guys, if your plenum is 28 inches wide and your air handler is 20 inches wide, 17 inches wide, then they're blocking off the rest of your supply plenum with a piece of ductboard. The supply plenum is not the proper size for that coil or air handler. So you need to recommend replacing that supply plenum to match the air handler or coil. 33 is duct insulation. Duct insulation is very important to the performance of your system. Check for old hard pipe that the insulation is deteriorated, old R4U ductwork, dry rotted, cracked or falling apart insulation. The old R4 value duct wrap on hard pipe after years is no longer R4. You may get R2 out of it, okay? Okay, duct insulation is R6 to R8. Fair, old duct but still in decent shape. Could be old R4 value ductwork and it could be fair, it could be in decent shape. Why would you talk to the customer then if it's in fair condition? Why would you talk to them about replacing ductwork? Because of the mold, mildew, and crap inside of duct systems normally. Poor, old deteriorated insulation, dry rotted, very thin, old R4. So duct insulation, the reason I have that on there is to make you think. R8 value ductwork, R6 value ductwork is better insulated, has better heating factor basically, or in cooling factor, so it has less load on the ductwork. You literally, say a 4-ton house, you can literally save 6,000 to 9,000 BTUs by replacing old R4 value ductwork with R8 value ductwork. That literally can cut off between 1/2 and 3/4 of a ton of air condition in your home for cooling capacity by replacing your ductwork with thicker R value. Very important. Duct type. Simply circle what type of ductwork you have. Circle all that are correct. If you got hard pipe in there some, flex duct some, and duct board some, then check all of them. Okay? Duct connections. You must run your hands around the supply plenum. Feel for air leaks. Duct connections also include the supply boxes and distribution boxes. Make sure that the correct collars are installed and not loose on the supply plenum air leaks. Okay, everything's sealed and no air loss. Leaking, air loss. Give price to repair, replace the plenum or whatever is leaking. Broken, could be hard pipe or collars broken in wrong sizes. So duct connections, when you get up to any air handler, guys, if you feel cold air blowing on you or hot air blowing on you, that's, whatever you're working on, follow that air leak and go to the source of it and give a price to fix whatever that air leak is. If it's a vertical system, and you got air leaks between your furnace and your coil, where your coil meets your furnace, you want to run silicone at that corner, at that bead across there. And that silicone will stop that air loss from blowing back out at you. Where your drain line comes out at, you want to fill it all with silicone, and because your hole may be this big, but your PVC pipe is this big, but the hole for the door is this big. Well, all the air leaks comes through that door. Well, run silicone all around up inside there, and then kind of use your finger and push it all in there and stop air loss blowing out at you. Okay. So we did duct insulation, duct type, duct connections is what we just did. Collars. So duct connections and collars could be close to the same thing, obviously. So your collars attached to your supply plenum. Do not put a metal collar on a ductboard supply plenum. It doesn't stay. Don't put a ductboard collar on a metal supply plenum. The only way you can do that is if you literally cut the flanges larger to where the flange basically bends all the way to the collar. So when you stick it in, instead of you sticking your hand in there and bending the flanges over on the metal collar, which are this big, you'd have to cut the ductboard collar, and then they're about this big, and you got to bend 2 inches of metal over all the way around, and then you still got to silicone the whole damn thing. Okay, to stop air losses. So if you put a metal collar on a metal plenum, then when you run it, you stick the collar in there, so when you cut the hole for that 8-inch collar, as you stick the collar in, there's a ridge around that collar that doesn't allow that collar to go and fall in unless you cut the hole too big. If you cut the hole too big, then you would push the collar in and you literally could push it all the way and it'd fall in there. Okay? If it is not too big, then it will stop at that ridge and not go in any further. At that point in time, you stick your hand in the collar and you bend the flanges of the collar inside the supply plenum all the way around it. And now the ridge stops it from going in and the flanges being bent out, stop it from pulling out. Now your collar is sealed, secured. Then you take silicone and you silicone the collar all the way around, not painter's caulk, not airlock. Not silver tape all the way around it. You just silicone it all the way around it, because silicone will dry. It's water proof basically, and it's going to flex as well too. So if you move the collar a little bit, bump it, whatever may be the case, you're not going to break the seal. So you run silicone around the collars. If it is a vertical system, then the collar should be in this position, sticking inside the supply plenum like this, to where you can grab the airflow coming out. If the plenum is like this, then your damper would be like this, so you can open and close your damper like that, so it can scoop the air coming in this way. If you put your collar or your damper like this, then you can't damper air like that. You have to turn it within, so it sticks in and the air grabs into the damper and comes in. Okay? Now, when I say collars, I'm also going to say, did you put the duct on the collar properly? So I put the collar on the plenum properly. I sealed it with silicone. Now the next thing that I need to do is I need to put the duct over the collar and seal that. So the flexible duct will slide right over the collar, and again, it also has that little ridge on the other side of the collar, where you, on the male side of the collar, where you will actually slide the duct over the male section of it. When I say male, because it's crimped all the way around to make it a little bit smaller. So then you slide the inside portion of your flex duct over that collar, and then you take it and kind of do like this with it a little bit, and you push it as far as you can over that ridge. You know, that little ridge is a little bump in the metal basically. Then you take a duct strap, pull a duct strap, tighten that duct strap up, pop off the excess to it. Then you take your insulation on the duct itself and you roll the insulation inside the silver to where all you have, you want the silver paper on the outside of the duct to kind of tuck in like this. Okay? Now remember, the inside of the duct is plastic. It's a slinky with plastic on it. It's over the top of the collar there, and it's strapped in. Well, what do you do if you don't have any strap? We'll get some black tape, 2-inch black tape, roll 2-inch black tape around it to stop the collar from pulling off. Then again, you roll the insulation on the inside, and then you kind of grab the insulation like this and you push towards the supply plenum and you do this with it. And it will just shimmy all up inside there, and you push it all the way to your supply plenum that is silicone on that seam. You take the damper and you shove it up through the exterior of the duct, the silver paper of the duct, and you pop a hole in the duct to where I can see the lever on the damper. Then you take your strap, because your plenum is here and your collar is here, and you got about this much distance between where your collar is and the plenum, and then you take your strap and you put your strap right here. And then the insulation, remember, is tucked in, so when you look at it, you see no pink or yellow insulation on the duct. All you see is silver. The silver is pushed all the way up against that supply plenum, and then you put a duct strap on it in order to hold the insulation up against your supply plenum. Inspectors want to see airlock around there. So then what you do is you take some airlock on a paintbrush, and between the duct and the plenum itself, you can literally just stick that paintbrush in there and just kind of do this with the paintbrush. And then the mastic will adhere the plenum to the exterior of the duct. And remember, your damper is sticking up through the insulation, the silver insulation, so I could go over there and start looking for my duct, my my damper, and I can find that piece of metal, that damper, on the exterior of my flexible duct. Your damper is like this. So if I take that damper, and this is the inside of it, and this is your wing nut up top with your little lever on it. So if my lever is facing this way, my damper is facing this way. If I turn it this way, my damper goes that way. So whichever way that damper is facing, that is the way the lever is facing, then the damper is facing the same way with it. So if it's this way, it's closed. If it's this way, it's open. If it's this way, it's closed. That's simple. Make sure you do not take a strap and put it over the damper, because now I can't move the damper. I want to be able to move the damper. And then you also have to take the collar and you have to screw the wing nut down so that the damper doesn't do this when the wind's hitting it. And you can literally hear the damper in there going because the wind's making it do that in there because of the static pressure. So you take the wing nut and you screw the wing nut down and you tighten the wing nut to where it's not pushing in the wind like that. There's so many little things that just come into every line item that you have to think about. Okay? Next one is your float switch. Well, you're checking the heating system. Why are you checking a float switch? I want to make sure the float switch is in the correct location. I could also pop the float switch off, which should shut the power off to the R, which kills the power to the system. I want to know if they have two float switches, one on the main drain and one on the emergency fan. I don't have two selections there. The float switches, I don't have a selection for the emergency pan float switch. I just say float switch. That means go check for both of them. What if it's a condensate pump? We came across that one, didn't we?
You want to actually take the condensate pump out and clean it physically.
Okay. So if I'm saying on 37 and 38, Christian, because we had a problem with this, right? And it says drain line and it says float switches. What should that now pop in your head?
Drain pump.
It should go everything with the drain line and everything with float switches. There's no need for a float switch on a vertical system when the drain line comes out, comes this way, and falls down and goes right into a condensate pump. There's no need for a float switch. Why?
Just right there.
Because it's not terminated and sealed. So if water backs up, water don't back up through the pipe and leak up top, does it?
No.
You know, so what good is a float switch way up here when the pipe is not sealed down at the bottom? It's just sticking in the pump. If the pump stops working, the water builds up in the pump and shuts the float switch off. So when I say float switch on there, what are you supposed to check?
Float switch and a condensate pump too.
So you pour water down the drain line, you want to know if the pump works. If you look at the hose that's coming up from the condensate pump, what color should it be?
It should be
Clear.
clear.
It should be clear. If it's brown, what is that telling you?
Pump's dirty.
It's probably gonna get clogged up eventually.
Yeah,
It's all the
and-
dirt and debris.
So how do you check your float switch now that we're keying float switch in? And now I see I have a condensate pump. What float switch do you need to go check inside there? If I pour vinegar down that drain line, it goes into my condensate pump. If I pour a bunch of water into it, then my pump ought to come on, right?
Yeah.
What's the next thing we need to do when it says drain line and float switches? You need to go to the condensate pump, unscrew it if it unscrews or just pops up sometimes, and you need to take the bottom reservoir off that pump and then go empty it and then look inside and it's gonna be full of gook because it probably hasn't been cleaned in 20 years. Then you need to clean the bottom part of the pump. So we went and did a PMA the other day. We blew the drain line into the pump. Okay, it's into a reservoir. Now that I blew crap into the pump, or blew water and air into the pump, you know what it did to all the shit that's in the pump that's never been cleaned in 4 years? It stirred it all up. Then when the pump came on, all that stirred up shit was chewing up inside there and burned the pump up. Then the customer literally could say, well, you caused the pump to burn up. Did you?
Yes.
You actually did. Because if you would have did your job, you would have actually went to the condensate pump, pulled the bottom of it off, cleaned it all out, put it all back together, poured your vinegar and water in it, it would have pumped and they wouldn't have had to change the pump. Instead, you blew the drain line, never checked it, and it burnt the pump up. It's partially your fault. The other portion of it that is their fault is they never maintain it and never pour vinegar down their drain lines. That's the other part of it. Okay. Drain line. What are we checking on the drain line, guys?
To make sure it has downhill.
Okay, what else?
You want to make sure it's insulated all the way. You want to make sure it's supported.
Yep.
Make sure it doesn't have any hills and valleys.
No hills, no valleys.
Where
It's
we
not
trap.
causing additional peat traps and run traps in it.
It's called a belly.
How
Yeah.
old is it? How old is the drain line? So if the house is 50 years old, what's the probability that the drain line's 50 years old? Because who literally goes and changes the drain line in the attic? It should be you, should be the answer. Okay? You should be the answer. Think about this. Rents due. Alright? You got a 25-foot drain line that's run horizontal, 20 feet of it is horizontal run, flat. That drain line is going to be full of crap. Charge the customer either to run all new drain line. Well, I don't have all the drain line on my truck. Okay. Charge the customer, go over there and cut the drain line and put a cap on each side of it and drag that 20-foot of drain line outside and run a hose through it and get all the shit out of it and bang it on the sidewalk and knock all the crap out of it and run a hose all the way through it and then go inside and then blow it from there, the last little 2 foot or whatever of drain line and clean all that out, which I'll cut it as close to the peat trap as I can so that I can literally stick some solder in there or something, solder stick in there to clean all that out and then blow that out. Then I put caps on both sides of the drain line in order to bring the rest of that outside if I don't have any new pipe. When you bang it on that sidewalk, you're making all that shit just get loose and then you run a hose through it, boom, you wash it all out. Now you can go put that same PVC pipe back. You can insulate it, you can glue it again, make sure all your seams are glued, right? Clean it all off, glue it again, and now at least you did that and you can literally raise the drain line up a little bit and you can make a downflow on the drain line as opposed to 4 feet come down, elbow over 20 feet. Now you need to get some supports, wood stuff in the attic, and you can support that drain line on a horizontal run all the way down in order to help the drain line from there on out. Peat trap. Peat trap is a U-bend on a drain line that holds water and prevents sewer gas from getting back into the air handler. All drain lines must have a peat trap, gas heat. When the drain line goes into a peat trap, there should be a vented pipe for gas heat to allow air to escape and water to drain.
That's the reason why installers always make sure they put a T and stub out. Just leave it open with a gas one.
Yep. Now, if you have an air handler, what do you need to do?
Make sure it has a P trap within 5 feet, correct?
Nope. Not within 5 feet, no.
You want to close it with the T.
you wanna make sure your drain line does not have an opening in it.
Yeah.
So, gauge, an air handler, I'm gonna tell you something about drainage you may or may not know. On an air handler, this is the most important thing. On gas heat, your coil is in the positive pressure end of the system, right? Whereas an air handler, your coil is in the negative pressure end of the system, in the return. Does that make sense to you? Okay. Air handler, blower motor. Drain pan is down here, drain line comes out, and boom, goes into a P-trap, okay? My drain line comes out, and then I have a T on my drain line. Okay, there's my opening in my drain line. The way this system is run right now, so here's my T, there's my little PVC pipe up, and it's got an opening on that. Will this system drain properly?
And that one is
Air handler.
air handler. And if it's open,
Mm-hmm.
then no,
Why won't it drain?
because your pressures will be off.
What pressures?
With the open tube, it's not gonna have
It's gonna start sucking in air, and the air is gonna run and suck in the pipe. That if you have a pipe with a T on it, and if air is sucking in the pipe and going to your air handler right here, okay, or to your drain line into your air handler, and the negative pressure is sucking this way, then air is passing through here, and this goes into a P-trap over here. Air is passing this way and not allowing the water from inside the air handler to drain out the pipe. If you have a gas furnace, then you have positive pressure air going this way, which is positive pressure is going out, which means it's blowing the water that way. So every air handler's got to have a cap on the pipe. If I come out and I do this, so here's my air handler here, and I come out and I have a P-trap right there, and it runs 25 feet over here, and it goes into the wall, and I don't know if there's a P-trap over there. I'm just gonna assume there is. Do I put another P-trap here?
if you know there's a P-trap,
Let's say I don't know. Let's say there's no possible way for me to find out either. That's for just making it up, right?
What was it like before? What was it like before the change up?
Before it was like this. But I don't know if there's a peak trap over here because there's a wall here and it's buried in and it's inside the wall and all that kind of, I just don't know. I literally, there's no way for me to find out either. So I got 25 feet from here to here. So again, here's my down, there's my wall right here, okay? So literally, this is going inside the wall, and it would be like a stud here and a stud here, and the PVC pipe would come up, and you'd have a P trap right here, and then you have a 3/4 line coming down in here, and you just can't see that there's a P trap in there, because it's only a 3/4 line shooting up past the stud.
I would say, I mean, I know a double P-trap isn't good, but like you said, it's 25 feet away. I would say still install the P-trap right there.
Okay, so you're gonna cut this line, and you're gonna install a P trap right here.
Yeah, I might be wrong, but that's what I'm saying.
Okay. If you're wrong, what's gonna happen?
It's not gonna drain.
If you're right,
It's gonna drain.
you know what I mean? Make you right, even though you're wrong. Here's how I make you right because of everything I'm gonna do, even though your answer's wrong. Okay? if I add another P-trap over here and I just can't verify this over here,
Yeah.
and I add a P-trap over here, then I have to add a T right here. Because once the water comes past my air handler into a P-trap and comes here, I need a vent.
If I don't know,
If you don't know,
okay.
I have to add a vent right there. Now I can have a double P-trap, but I have to have a vent after my P-trap. So this portion of it allows the air handler to drain.
Mm-hmm.
After it passes through here, I have to let my air escape for it to drain. If there's another P-trap right here.
If I don't know.
Yeah, because if this fills up with water right here, I got water right here, then this can't drain because I have nowhere to displace the water.
I mean, obviously, like, before the change out, if you didn't have a P-trap right there before, like, I wouldn't put a P-trap right there, but
Okay, it's not a change out, you're going for a service call.
going for a service call.
And there's
okay.
water all in the emergency pan and the drain line's not clogged.
Doesn't mean the last person did it right.
Yeah, and you just don't know the answer.
Yeah.
Somebody else installed it, you didn't.
So what would be the correct answer if, like, the P-trap was behind the wall, like, without the first P-trap?
So you get there, there's water in the emergency pan. Somebody else installed this system a month ago, and ever since they installed it, they're tired of calling the same person out over and over and over again because nobody's ever been able to find out why I got water in my emergency pan all the time. Well then, I'm gonna go find where the drain line drains to, and it disappears, and I just don't know where it's draining. I just don't know. But I know it was running like this, okay, just without the P-trap,
Yeah.
okay? Or let's just say they put a P-trap in, and it was running, but the system's not draining. Well, I'm gonna solve your problem whether they got a P-trap or no P-trap. It doesn't matter anymore. I put a vent stack on here, and I just solved your problem.
You still leave it open?
Yeah. Because it's past the P-trap, and the stack has to go higher than the air handler. So if water backs up, it don't overflow there. That make sense? How that works. Because if you got water in the drain line and it's clogged up, that's easy. You blow the drain line.
Mm-hmm.
You get there and there's water in the emergency pan and constant water, then okay, where's the water coming from?
You know it's not draining.
Well, because the air is not allowing the water to drain here because the P-trap, the vent stack is not there. It's not allowing it to drain. It builds up in the pan, overflows in the pan, overflows inside the air handler. The bottom of the air handler is now wet. It's 98 degrees, 120 degrees in the attic. The bottom of the air handler with water in it is going to sweat, which is going to drip down at the bottom of the air handler and fill the emergency pan up, and it's never going to stop filling the emergency pan up. Because until you dry the air handler out, put a stack in here and vent it, and literally run that air handler for a day or two to dry all the water inside the air handler up. If you turn the air conditioning back on, I'm telling you, and you got insulation at the bottom of this air handler, and the bottom of the air handler is wet, and you turn the air conditioning system back on, it's going to make the water cold, which is going to make the metal at the bottom of the air handler cold, and it's a cold glass effect, and the air handler is going to sweat. And you're not going to stop the water from dripping in your emergency pan. That's the reason they called you. There's water in the emergency pan. You run your hand on the bottom of the air handler, it's soaking wet. How do you stop it? You gotta dry it first. If you don't dry it, you're never gonna stop it. Boy, if you don't remember that, you're gonna get so many callbacks in your lifetime, it's gonna be ridiculous. Trust me on that one. So we just went over P-trap, we went over 39. And that's all the stuff I just talked about, what we just did right there with P-traps and clogs and drain lines and all that kind of crap. Rubber Tex, 40. The black insulation on the drain lines code, we use 3/4 wall for all of our drain lines. Drain lines should be insulated from the coil all the way to the termination point at the P-trap. Insulate completely to the P-trap from the coil. Not finished means if it's not all the way to the P-trap, sell it and finish it. Sell it means sell the insulation and finish insulating it. None, sell it and install it. 41 platform. All platforms for air handlers, gas heat systems should have a rise on them. Install the platform as high as possible to allow great downflow or downfall on the drain line. If possible, 2 to 3 feet if we're installing a new system. Then secure the drain line for proper downflow. Rebuild all platforms for new installation. Upon servicing, check the platform for being level, rotted, not supported. Make sure the platform holds the emergency pan as well as level. So we're going to build a platform here, 2x4 platform. So our 2x4 platform is going to come all the way over here. Okay, and our plywood is all the way here. And our emergency drain pan is literally going to sit on top of the plywood. So my platform has got to be level. My platform's got to be as big or bigger than the emergency pan. If I have a furnace and a coil, and my coil is attached to here, okay? Then my drain pan would, or my platform would actually extend out this way.
Past the coil.
Yeah, past the coil, and then my drain pan, if this is a gas heating system with a coil, then my drain pan would start here and then come here, and still supported by my platform. And then I would have a heater stand holding my coil up, and a heater stand holding my air handler up or my furnace up as well. Platform is very important because if it's leaning to the back, then your drain line is over here, and if it leans to the back that way or leans this way and your water's not going where it's supposed to go, and I'm telling you to go check your platform, you ought to take a level out your toolbox and just put a level on it and say, he went to one out of the day and it was draining the wrong way, right? Mm-hmm. Sometimes you're going to look at a vertical system and you go,
vertical system, you could tell, obviously.
yeah, and you're going, so he takes a picture of the level and everything. I only want it to just drain. I don't want to do anything else.
R22 system.
R22 system. It's leaning like this. The drain line's over here. Well, how can you make it do that then? They just got finished rebuilding the platform and it went level. Can I take my flat bar and stick it up underneath the furnace and push it up and kind of make it do this? And then put little pieces of wood up underneath it? No, we can't do all the crap. No.
That's what they wanted me to do.
I know they would. Yeah, just rig it, you know?
Yeah.
No, I'm not rigging it. No, if you want me to do it, I'm going to do it right. Because as soon as all that shit rots out and all that kind of crap, and they ain't done right, and then somebody else is going to come in here, hey, look at the work they did. They crappy, man. Look at the shit they do. They charge you to do this? Yeah, he charged me $200 to put some, I had some little cars and some pieces of paper, and he just stuffed it up underneath there. No, do it right or don't do it. Do it right or don't do it. Okay? So your platform's got to be level. It's got to be high. On a gas heat system in the attic or air handler in the attic, brand new installation, I'm going to put legs on this thing.
Mm-hmm.
So I got 2 feet now, 3 feet, whatever. And I'm going to build that up. So now my drain line comes out, can have a downflow on it. Boom. Okay? Make sure that platform is right, guys. I've sold entire new complete installs using their existing equipment because whoever installed it just did a shitty job installing it. I mean, just pathetic job installing it. And when I go look at it, I'm like, man, we just did one the other day. We put two new plenums in, right? Two new plenums,
Two
all new
ductwork.
ductwork and everything. And somebody had just installed that furnace and coil no more than a few months ago. Okay? So he just bought the house where the previous owner had the two new air conditioners put in before he bought the house. So he's trying to get everything as cheap as possible. And so he calls us out, we go over there, and I sold him a $13,000 job. Run all new ductwork for two systems, new supply plenums, put platforms in, float switches in, Remy halos in. It's $13,000. Redid all his ductwork, everything.
Speaking of that, ever since that job, you know, after we finish this, can we go over like, you know, duct sizes, CFMs, and if that's cool?
All right, 42 is catwalk. Why do we want a catwalk over to the system, guys?
Safety.
Safety, safety, safety. Plus, it's code.
It is.
It's code to have an 18-inch catwalk all the way over to the system. And you want to have that catwalk secured.
Nowadays, you just like fully deck the attic now, right? Basically.
On new houses, yeah, they're doing that. But, you know, your old houses, things of that sort, you can sell a catwalk over to the system. If I go install a new system, guys, I'm selling a catwalk. If you're going to service a system, are you selling them a catwalk?
Yes.
Yeah, if they don't have one.
I could.
Yeah.
Okay, so when you gonna put the catwalk in, are you gonna do it before you go service it, or are you gonna come back later and do it?
I'll probably come get a price and come back with a
Give them a
crew.
price and come back and do it. Okay. So I always say before you go pull a unit out, before you pull the old system out, I want you to, here, let me make a couple copies. Before you pull the old system out, I want you to take the air handler or catwalk, and I want you to build a new catwalk before you pull that system out. Because as you're pulling the old system out, I want you to have sturdy ground to walk on before you pull the old one out. Okay? So having a catwalk, as soon as you walk in the attic, I want it plywood right there. Not 3 feet from there, because you're going to constantly be right at the top of that attic. So I want it plywooded all right there. On both sides. So the furnace is over here, and as you're climbing up this way, I want plywood here, and I want plywood here when you walk up. When you go over to the unit, I want plywood in front of the unit. I want some plywood over here by the supply plenum, so when you're putting the ducts on, you're on plywood. I want it on the other side of the air handler where the ducts are, because when you're putting ducts on over there and putting your plenum on and everything, you have plywood to stand on and you're not falling through the ceiling. Okay, so it's important, guys. Your next one is attic stairs. Attic stairs, a pull-down staircase that allows access to the attic. This must be the clearance to bring the heating system, this must have the clearance to bring the heating system out of the attic. A catwalk should be installed from the attic staircase. A catwalk, should be installed from the attic staircase. The staircase should close and seal properly for minimal air leakage. Recommend attic staircase tent for insulating and sealing the attic door. Your attic staircase opening is a 24 by 54 spot on the ceiling with no insulation and air gaps around the ceiling. So attic staircase, attic stairs. Okay, stairs installed correctly. What are you doing? You're supposed to pull in from here. Okay, staircase installed correctly and sealed with attic tent. Leaking, all attic staircases leak unless they have an attic staircase tent on them. Covered, some sort of tent or insulated cover over the hole. 44 is insulation. Look at the attic for how high the insulation is in the attic. 11 to 12 inches is R30. 5.5 inches is R19. 3.5 inches is R13. So, when you walk in somebody's house, in somebody's attic, guys, this one you get back. You look in that attic, the first thing I want you to think about, which a lot of people have no clue, they just don't think about these things, and that's why, again, if I'm going over these things with you guys, what am I trying to do? I'm trying to give you a point that every time you look at line item number 44 on your service invoice, when you look at it and it says insulation, here's what I want you to think about. You climb in the attic, and the first thing I want you to think about is, do you have a 2x6 on your ceiling or a 2x4 on your ceiling? Or a 2x10 or a 2x12? That's the first thing I want you to think about. So when I'm thinking insulation and I go in the attic, the first thing I want to go is, what kind of flooring do I have? 2x6, 2x4. Does anybody know what a truss roof is? Anybody know what a truss roof is? Yes or no? No? Okay, you know what that is? Mitch, you know what a truss roof is?
No, I've heard of them.
You've been in it. You've been in that attic with a truss roof. I know you have.
Oh, it's like the attic at your brother-in-law's house.
Nope.
No, that's good. That's
Nope.
trust. Wait.
So a truss roof is like this. Here's your roof line like that. And then this would be a 2x4, okay? And it would be like this.
Okay.
You ever been in an attic like that? Where this roof line is all the way through the attic and you gotta climb through all these things in order to get wherever you go.
Yeah, that's like old houses, right?
Yeah.
Or in the French Quarter.
French Quarter, no.
You got to
I've
transport them.
been through one that was in the city. It may not have been in the quarter, but in the
Yeah.
woods.
I mean, these are normal, what we call track houses, okay? So, the reason for a truss roof line is if I have a wall right here, so here's the exterior wall, here's an interior wall, here's an interior wall, here's an interior wall, here's an interior wall. I can literally eliminate all these walls right here on a truss roof. Because the way it's working is, this is holding up my roof, see, my ceiling. So you can remove the interior walls. Now, when I see a truss roof, here's what I'm thinking of. Every time I see that truss roof, that's a 2x4. And I see 3.5 inches. And then I see insulation right here. And I see the top of my 2x4. So what does that tell me?
Not very well insulated.
R13 or R11.
Okay.
Okay? That's what that told me. So again, I see insulation on my paperwork. I see studs in my attic. Okay? And this is why. That's a R4, a truss roof with 2x4. So if you have a 2x6 here, the 2x6 here is 5.5 inches. R19. If I got a 2x12 and it's completely covered in insulation, then I have R30. So if I have a 2x6, 5.5 inches, okay, and insulation's piled up like this, what do I have? R30. So based on the stud that you have, should tell you how much insulation you have in the attic. Make sense? Different way of looking at insulation, huh? Looking at the stud to see what kind of stud you have. All right, because you know how thick the stud is. Gauge your insulation from there. Alright, last but not least is 45, which is other. Anything that is not covered on the checklist, put it here. What did we put on the checklist for your electric furnace, electric air handler, Christian?
Capacitor on the blower motor.
Alright, what else did you check that's not on there?
For the air handler?
Yeah, that you did the other day, you sent me a picture of.
The CFM.
CFM, that's where you go to.
Yeah, that shit helpful.
Isn't it though?
Yeah, it really is.
Yeah. So that's what I'm saying, guys. I mean, just using the stuff that you have to check these different things and doing the extra little shit. And I'm telling you, when you are brand new in this business and you are taught to do the extra stuff, man, you're the 1% out there doing the extra stuff. And if you don't think that is going to teach you 1,000 things that other people don't learn, God, you just don't know yet.
Makes you a better tech.
It makes you 10 times a better tech. A better tech, 99% of the times, is just the guy who's thorough. Because all these things on this invoice, guys, 90% of it is visual. What's the difference between a jackleg technician and a thorough technician? The jackleg could do. Yeah.
Go fix what he's there to fix the
Yeah.
You can walk away the moment it starts running again.
Yeah. So, take all these little things, guys, and when you do your heater check on everything, look at all these little bitty things, man. Look to make sure that the triggers in your head of indoor air quality and blower wheels and blower motors and cabinets. Well, why do I have freaking cabinets? Filthy, because I want you to talk about indoor air quality. So if I get to the end of the year and I go, Gage, well, how many Remy Halos you think you sold out this entire year? And you go, none. And I go, but how many PMAs did you do? About 500. So you did 500 PMAs, and out of 500 people, how many of them did you talk to about indoor air quality? None. That's why you didn't sell any Remy Halos, and you didn't do the entire job, because I asked you with like 5 questions to talk to them about air handler, about indoor air quality, and you went to 500 and you talked to nobody about indoor air quality because you didn't have a presentation, because you didn't do any homework, and you can't even like just tell them, hey, we have a Remy Halo. Look, here's a video. They're $1,100 installed. Here's a video. Would you like it? You ain't even got to do the presentation. It's better for you to do it and then give them the video. But if you just give them the video is going to sell you some. If you never talk to them, never offer it, never tell them about it, they will never buy it. They're not going to go, hey Gage, you got any Remy Halos you can install for me? Somebody told me you install Remy Halos, is that correct? Yeah, I do that. Nobody's going to do that for you. So, we have now completed the videos for a heater check, for electric heat, for gas heat, and we did the other section of the gas heat video, which is all of the duct system and airflow and indoor air quality. And now, if you watch this video and the other 2 videos over and over and over and over, man, it's just going to make a world of difference for you, and you will learn how to do these heater checks and what I want you to go look for, and how often are people not doing all this kind of stuff. So one of the things that Mitch just put together, he went to Home Depot this morning or yesterday, and he bought him a foot of wire for each one of these, and then he put a tag on them, which is just really cool. And he goes, okay, hey Home Depot, give me just 1 foot of number 2 wire is all I want. Okay, there you go, here's a foot of it. And they put a little tag on it, and he paid $3 for it, whatever. I need some number 4 wire, can you give me some number 4 wire, and I just need a foot. So he goes and puts a tag on it, puts a number 4, and he has the wire size right here and a number 2 wire right here. And then he goes, okay, well, I also need number 6 wire. I need 8 wire, I need 10 wire, and I need 12 wire, and I just need a foot of each of them. There you go. He makes him a little deal, so if he goes over to the ear handler and he goes, that looks like a number 8 wire in there, and he goes and he matches a number 8 wire up against it, and he goes, huh, there's my 8 wire. Damn, that's bigger than that. So he puts a number 4 to it, and he goes, shit, that's the same size as a 4 wire. That's a number 4 in there. He can literally take this, which is really cool that he did this. And you know what? And nobody told him to go do this. I think I mentioned it the other day that just go to Home Depot, go get you some wire, take it upon yourself, and stop asking me to do everything for you. Grow up, being adult, and do things for yourself. He's learning off of this. That I told him, I'm not sending you out and go and do a bunch of heater checks if you can't tell me wire sizes. Now he just pulls this out of his toolbox and goes, yeah, there's a number 2 wire. Yeah, there's a number 12 wire. Good job, man.
Right.
Good job. Great job, man. You know, taking things, instead of me having to do things for you all the time, that just burns my ass that people just don't take it upon themselves to do things to help themselves. I'm going to talk about tools for a second. So, I just bought some manometers. Took the manometer home. Did you use it this weekend?
Yeah, I use it and I brought my own
Good. Great. Where's mine?
on the truck. I'll give it back to you.
Yeah. With all the pieces to it too.
Yeah, I ain't never opened it.
Good. Alright, so a manometer is going to check water column pressure. So if I say, hey Gage, I need you to go check this gas furnace over here. Do you have a carbon monoxide detector? No. Do you have a manometer to check water column pressure? No. So how are you going to check the gas furnace? If you can't check some of the things that I literally need you to check. How are you going to check that there is no carbon monoxide getting in that house and what the levels of carbon monoxide are? How are you going to check it? Well, I can't. So if you can't check carbon monoxide level in that house and you turn around and leave that house and you kill that family the next day because they do have carbon monoxide leaks in there, it ain't gonna feel too good, is it? You literally killed the family because you were too cheap to go buy a carbon monoxide detector. And I go, well, no, I'm not, I wasn't too cheap. I can afford a carbon monoxide detector, but well, why didn't you go buy one when we've been talking about it for 2 months, 6 months, 2 weeks, 2 days, whatever may be the case. And we're finally gonna go out and go check heating systems. Then you need a carbon monoxide detector to test your supply vent to see if you're getting a carbon monoxide level that is unsafe for that family. Why are you doing the heater check? For safety. That's it. You're doing safety checks. Okay. So when I have a carbon monoxide detector and I'm going to check for carbon monoxide and I go into everybody's house and I test that carbon monoxide in everybody's house and I run across one that's got a high level of carbon monoxide in 100 of them that I go to, was it worth it? Because that one that I found, I could have saved somebody's life, literally could have saved somebody's life, because this is no joke. Carbon monoxide kills. But number 2 is, I don't know how much the carbon monoxide detector is off the top of my head, it might be $80, okay? If I sell one furnace, will it pay for the carbon monoxide detector? Okay? I buy a leak detector for $320. I sell 2 evaporator coils, and my commission's just paid for the leak detector. I can sell 2 evaporator coils probably within a week or 2. So I spend $300 to get the tools I need. I sell coils like crazy because I actually go do leak detections. I sell new systems like crazy because I actually use my leak detector and I go find the evaporator coil leak and I go, man, you got an R22 system, you got a Freon leak, you really need a new unit. Man, you got a leak in your evaporator coil, your system's 15 years old, it's a 410A system. I could replace your evaporator coil in there, or I could replace your entire system and upgrade the entire system. Ma'am, you got a leak in your copper line right here. I can solder that line up and get you running. Everything else looks fine on your system. Ma'am, you got a leak on your dryer right here. I use my electronic leak detector. Ma'am, you got your caps on your service valves are leaking. So here's the deal. Christian was just out of this job yesterday. I'm making this up. And he goes and does a spring PMA, and he takes a picture of his gauges. And his gauges say his pressures and temperatures and everything is working properly. But before he leaves, he forgets to put the caps back on the service valves. 2 weeks later, they call up and they say they're not cooling. Gage, we send you out there. You walk up to the system and you see the Schrader valve caps are sitting right next to the unit. And you just look at the unit, you hadn't put gauges on it yet, you hadn't touched it yet, and you can see the suction line is not sweating, the condenser's running, compressor's running, the suction line's not sweating. The first thing you need to do before you put gauges on the system, and you feel inside the house it's not cooling, or you grab the suction line and it's cool but not cold, probably low on refrigerant, before I put gauges on it, before I touched anything. I know he was there 3 weeks ago, 2 weeks ago. And I look back and I see his gauges on the picture, right? Because he uploaded pictures of his gauges and they were perfect. And I'm looking at this thing now and I'm going, it don't look right. It's not cold. Let me grab my leak detector before I put my gauges on the system. Because as soon as you put your gauges on it, you depress that Schrader valve pin in and you may seal it. Whereas it may not have been sealed when you took it off. Okay? So you take your leak detector, you run around it. Okay. Take your caps, put your caps on them real tight. Put it around it again. No refrigerant leaks. Okay. Now let me put my gauges on the system. System's low on refrigerant. You look at his, you look at yours now. 3 weeks later, he left the Schrader pin valves off, caps off. Go get the Freon, put Freon back in the system. He caused it. That's it. End of story. But you found it with your leak detector and saved a ton of time, as opposed to you got there, put gauges on the system. Oh man, you must have a leak in your evaporator coil. Well, he was just here 2 weeks ago. And then, well, you probably got a leak in your coil. And let's just say this is one of my customers I've been having for quite a while, and she's just she calls me up and she goes, I don't know, because it was cooling fine before your guy came out here 2 weeks ago, and now it's not cooling fine. Now your next guy tells me it's low on refrigerant, and I got leaks in my coil. Can you look at this for me? And I look at the pictures, and Christian's pictures say pressures, temperature, superheat, subcoolant's perfect, man. Gauge, you put your gauges on the system, and they say it's low on refrigerant. Tell me about it when you got there. Well, the caps were off when I got there and I put the gauges on. I know he left the caps off. I didn't write it down on the invoice, but he left the caps off. Okay. Then he left Freon. He didn't let Freon out. Freon got out of the system because he didn't put the caps on. But you could have found out with a leak detector. So you spend $300 on a leak detector. What are some other things that you need as a technician? Do you really and truly need digital gauges? Mitch?
Yes,
Why?
because the new digital gauges are miles apart from those old, just a high and low gauge. It's the information it gives you. It figures a whole lot of stuff you would have had to figure in your head.
Gives you a vacuum gauge.
Yeah.
Gives you superheat, subcoolant.
Right.
Gives you suction pressure, your head pressure. Gives you saturation temperature. It gives you everything. Man, but that's $700. I know. The answer is, I know.
But look at what it said. That's $700. Look at how many different.
You got to use it every time you go to somebody's house, and you're a service technician. It's $700. I know.
Well, when you,
You need gauges. I know. It's $700. Man, but that's, I know. It's $700. Go buy them and we'll take it a little bit out of your check, a little bit at a time. So it don't hit you. Hey, I don't have $700. No problem. Go buy your gauges. Take care of them. They're mine until you pay for them. We gotta take a little bit out of your check, a little bit at a time, until you pay for them, and then you're good. No problem.
finish paying for all of my tools.
When you go put gauges on the system, I want you now to go check superheat, subcooling, delta T's, the whole 9 yards of all this stuff. I want you to go check all this because when you use your gauges, you are going to find a ton of systems low on refrigerant, too much refrigerant in the system, bad superheat, bad subcoolants, restricted TXVs. You're going to find all this stuff and we're going to make tons of money because you actually have gauges that tell you this. That simple. Okay? What are some other tools you need? You need a wheel puller. Why do you need a wheel puller? Mitch, you know that one.
I had to, Eric had me doing work on this unit out there, had me pull the squirrel cage out and the motor and everything. I needed to clean the wheel. I had to get the motor off to do that. And it wasn't like I could just set up two 2x4s and with a hammer and bang that thing through that. I need a wheel puller that's specifically made to pull a wheel on a blower, a squirrel cage.
Just pull right. You got to sand down that shaft good. You ever pull the blower wheel up? Blow the motor out? So you need a wheel puller, but before you ever pull a condenser fan motor off or blower wheel off, just trust me on this and just do what I'm telling you to do and don't falter from it every time you do it, okay? And it'll save you so much time that you won't know to do it, alright? You always have sandpaper in your truck. It comes in rolls. It's only this wide, you know? And cut a piece off, yay big or whatever. So I gotta change the condenser fan motor. First thing I'm gonna do is I'm gonna take my sandpaper and I'm gonna, on that shaft, and I'm gonna make that shaft just shine as much as I possibly can. Then I'm going to take my set screw that's on it and I'm going to take my set screw off. And then I'm going to shoot a little WD in it or penetrating oil, whatever may be the case like that. Now I'm going to put my wheel puller over it and that bitch will pull it right on off. Okay, with no problem because I sanded it all down, made it all shiny, put a little oil on it and it will pull right off. If you try pulling that wheel off of there and your shaft is all rusty, well the rust is doing this to your shaft and it's not coming off of there. You got to sand it all down. Okay, on a blower wheel itself, sometimes they're just stuck like a son of a gun, and they won't come off. You gotta sand those wheels down. So sandpaper and WD-40 or penetrating oil, and that blower will come right off if you have a wheel puller. No problem. Okay, at $45 for a wheel puller. You need a coil gun. What is a coil gun? It kind of looks like a gun. It's a hose nozzle basically that you press in. And then the coil gun has got a reservoir that you pour some condenser coil cleaner in it and you screw it up to it and it's got a little nozzle to it up in the front and then you take that and it pulls the chemical in, mixes it with the water and you spray the condenser down with it and you foam all the dirt out of the condenser coils. So a coil gun is about $60-70 or so. You definitely need that.
It's 85 at Cobra.
85, there you go. You need an electrical meter that reads microfarads. Okay, so you test in your capacitor, you test in amperage, you test in voltage with all that. You definitely need that. You need a manometer. You need a manometer that's checking inches in water column pressure because you want to have enough intelligence to check your static pressure on your system and know why you're checking your static pressure and what does it mean when you check your static pressure. I'm telling you guys, if you learn how to check your static pressure on your system, you are in the top 5% of technicians that even know what static pressure is and how you check it. Or water column pressure, or gas pressure. Very few people know how to do it, okay? It's just tools, man, just tools. You know, nut drivers, you want to have that, lineman pliers, channel locks, all your standard normal tools. It's
Wire
your
strippers.
meters, wire strippers, yeah, it's your meters and your gauges. Those kind of tools are what is gonna make you money. Oh, here's another tool for you. You want an ECM motor tester. Well, an ECM motor tester, you actually have to pull the plug out of your variable speed blower motor and you hook it to this module. And when you hook it into the module and you hit on it, the blower motor comes on. Okay? You plug your motor back, or your module, your wire harness back into your motor and the motor doesn't come on. The problem is your circuit board. Okay? So an ECM blower motor tester, the module tester, you plug right into the motor and the motor comes on, the motor's good, it's your board bad. If the motor don't come on, it's gonna be your motor. Because you supply 24 volts to that ECM motor tester, and you just hit a little switch and it turns that motor on. If it comes on, your motor's fine, it's your board. Alright? So you definitely need a variable speed blower motor tester. That's probably 120 bucks or so. Okay?
I'm sorry.
You need a barbecue lighter. Because you need to be able to hit the little flame rollouts, right? I'm going to tell you that, boy, it really helps a lot. I'm not saying you definitely have 100% need, but I'm saying it really helps a lot if you have a little snake camera. And those little snake cameras really are not that expensive. You know, 150 bucks or so. They're really not bad. That thing you can pay for itself in a week's time, 3 times over. Your snake camera. You use it, man, on a regular basis, checking coils. You go check your gas furnace for your heater check. Pull your limit switch out. Don't take your camera, shine it on your evaporator coil. You take a picture of it and you go, man, you got a dirty evaporator coil. $700, change your coil, clean your coil out.
Blower wheel too.
Lower wheel too, yeah, you can take pictures of that, yeah.
Inside of you.
You know. How about your return air when you have an air handler? Okay, you take the snake camera and you can actually drill a hole in the metal or something, or you can pop the corner of your return plenum off, snake camera in there, and you can see if your coil's dirty. Man, that snake camera can make you some money, man. It can make you some money, okay? You need a laser temperature gun. Harbor Freight, $25.
No more Harbor Freight, man. I've
Right,
had a
right.
bad experience.
$25, man.
Home Depot.
Okay, Home Depot, $57.
They have the Amazon Basics that's just a ripoff of Home Depot's for
Yeah.
$30.
There you go. So, you need these tools, man. All these tools that we're talking about, you need these tools in order to test all this different stuff you go into. But more than anything, is you need to know how to use the tools. So if you are just starting in this business and you don't know what all these tools do, buy one, then say, here, how do you use this? Or how about this? Just go to YouTube. And it'll tell you how to do it. In 10 minutes. You don't even have to ask me. In 10 minutes, it'll tell you how to do it. Okay? But then when you go to customer's house, you are now going to know how all this stuff is done. Okay? We wanted to go over CFM. We'll do that real quick, and then that'll be the end of this video. This duct system, this whole deal here is telling you CFMs with different ducts. So I give this to the technicians so they have a quick reference on what duct sizes, how do you count your ducts? So when we install a new system, if I sell a new furnace coil condenser, and no, I'm not selling all new ductwork in this particular case, and my installers are going out there to install the new system, the new 4-ton air conditioning system that had a 4-ton unit in it before, got a 4-ton in it now. So I'll blame it on me here, okay? I'm the one who sold it and I didn't go look at the ductwork, all right? So the installer, when the installer goes to remove the existing 4-ton air conditioned furnace coil condenser, vertical, in a closet, they remove the supply plenum, and my proposal says reconnect to existing ductwork. Then when they remove the supply plenum, the very next thing they are trained to do and have to do, they have to go measure every duct that they just disconnected, which is doing what? Just go to your collars on your plenum and just go measure the holes on your plenum. I got 110, 1/9, 3/8, and a 6. So if I got 110, 1/9, 3/8, and a 6, and I have flex duct, what's my airflow, guys? 1/9, 110, 3/8, and a 6. So a 10 is 4. That's hard pipe, I'm sorry. My flex duct is on the right hand side. So a 10 is 275, 200, that's 475. I had 3/8. 475 and 450 is 925 and a 6. So I got 1,000 CFMs of airflow, right?
Yeah, that's not enough.
I had a 4-ton air conditioning system, didn't I? And I just made the ductwork up as I'm
Yeah,
just
that's
calling
not
it, right?
That's not enough ductwork for a 4-ton.
So what I need to do?
You gotta add more duct or increase your duct size.
You can't increase your
I'm
reach, you
gonna
gotta
say-
increase your duct size.
No, I don't. Because here's what you just missed. Because this has happened a bunch of times.
Or you gotta go smaller in the unit, correct?
First thing you have to do is determine what? What area are we cooling? So here's what happens.
Home, right? Square footage of the home, right?
Square footage of the home, how tall are your ceilings, windows,
Yeah.
all that kind of crap. Heat load. Alright. So we sold a furnace coil condenser 4-ton system. Alright. I'm gonna give you one that one of my salesmen sold years ago. It was a 5-ton furnace coil condenser, 2-stage system. My installers are going out to install it. I have never been to this house before, so I've never seen it. I know the subdivision. So when I'm heading over to the house, I pull up in the subdivision and I get over to the unit and I go look at the unit. They have the condenser in the backyard. It's not set yet. The air handler's not set or anything. I got over there fairly early. And it's a 5-ton air conditioner they're fixing to install in this home. The salesman did a manual J heat load on the home and said that you need 5 tons of air to cool this house. So I go over there and I look at the house, just pulling up in the neighborhood. This neighborhood is not a 2,500 square foot house neighborhood. Okay, but maybe they got an addition on the back of the house that I can't see from the street, right? So I walk to the back, go look at the condenser. I'm like, 5 tons, man. Let me go walk around the backyard and see if they got another room back here, another addition, whatever. Nope, standard house. It's okay. Let me go walk through the house. Let me go see how the house is built to see if there's anything special about the house that would require 5 tons. 8-foot ceiling, standard built house, you know, over there in West Wego, and I'm like, the guy's name, no matter guy, the salesman, I went and talked to him. I'm like, dude, you put a 5-ton air conditioning system in this house. How can you put a 5-ton air conditioning system in this house? He goes, well, I did a heat load on the house and it come out with 5 tons. I'm like, there is no possible way you can put a 5-ton air conditioning system in that house. It's no more than like 1,600 square feet. So right then I went ahead and got my laser out my truck and I went and measured the house. And it was like 1,600 square feet. And it had some things like a cathedral ceiling in the back room and things of that sort, which increased the heat load of the house. I'll walk around in every room. So what I do is I'll take and I'll draw out the whole house. And I'll walk through each house. And after we pulled the unit out, we counted the ductwork, and the ductwork was in the neighborhood of about 1,200 CFMs of airflow.
It's like a 3-ton.
Right. So as I walk around the house and I'm looking at his drawing, because he's got a drawing of the house and he's going, we're going to put a 9-inch duct in this room right here. Well, the room was nothing more than 10 by 10 in the center of the house. I'm like, you can't put a 9-inch duct in a 10 by 10 room when it's like 3 feet off of your air handler. You can't do that. So before we installed the system, I took the system back to Lennox. And I had to now go talk to the customer about putting a smaller unit in their house, and we have the wrong price on it. And this has happened many times that I've had to do this. So Arnold called me up and he goes, we're fixing to install a 4-ton system here and they only got 1,000, 1,100 CFMs of ductwork. What do you want to do? Stop. Do not solder the condenser in. Do not put the furnace and coil in, because this is, as you pull the system out, you have got to check this before you pull the shit out the boxes. Okay? So I gotta go over to the house, I gotta go walk through the entire house, and I gotta go, sir, ma'am, whatever, you do need a 4-ton air conditioning system in this house, whatever it is, okay? You do need a 4-ton air conditioning system in this house, but when they designed your house, they only have 1,100 CFMs of airflow. So I walked around your house and you don't have any ductwork in your laundry room, nothing in your bathrooms. You only got one duct in the master bedroom and it's really in the wrong place. Yeah, the master bedroom gets hot. And then your living room's only got one duct in it and there's no duct in your kitchen. So we need to add, and this particular house I just told you is a house in Woodmere. It's a standard built house in Woodmere, the one I just described to you. I mean, it's standard. So we need to add about 400 CFMs, 500 CFMs of airflow to your duct system to make 1,600 CFMs of airflow in your home, because your particular house is about 2,000 square feet. The other one we're talking about was about 1,600 square feet. So on that one we were talking about, I had to go just put a smaller air conditioning system in because I had to kind of resize it. On some of these other ones, Arnold called me up and he'll look at the duct system and he'll go talk to the customer about adding ductwork because you don't have enough ductwork, because we're trying to get 1,600 CFMs of airflow out of that system. You can't push 1,600 CFMs of airflow through 1,100 CFMs worth of ductwork, or can you?
Every vent gonna whistle. It's gonna have too much noise.
You can still do it though, right?
Yeah, but it's not how practical. Who wants to try to sleep at night with whistling sound every room, living room, kitchen, bedroom?
Right, but it can be done, right?
Yeah.
Yeah, a lot of things can be done, but is it right?
Nope, it's not right.
Okay.
So then you have to look at what is the velocity of airflow that you want for a residential air conditioning system. Do you remember that?
I don't remember it off the top of my head.
Velocity of airflow is 550 to 600 feet per minute of air. Okay. What's your static pressure on your air conditioning system?
0.05.
That's from the factory. That's a standard 0.5 static pressure from the factory. That's what they designed the air conditioning systems for. If you don't have enough ductwork, your static pressure is going to be high. Okay. If you have too much ductwork, your static pressure will be low.
It's not enough.
Well, too much. Yeah, not enough static pressure, right? Correct. So your velocity with not enough static pressure will be trickling out. Okay. So therefore, where your ducts physically sit in the room make a difference. What kind of air conditioning you put in make a difference of where your duct should be. So this is a long room right here. And I've got a duct here and a duct here on the side, and they blow out across the room. So if I only had one duct in here, where would I want the duct to be? I would want it to be like right here. Because when the air would come out, it has to go back across the room in order to get out of the door. In this particular case, I got them on the sides blowing across the room, which are fine. Velocity of airflow, where does the duct sit? And then how big is the duct? Does it cover that CFM of the room? So Gage, we were talking, your son's room does not get cool. Is it a cathedral ceiling, I think you said?
Yeah, it's really tall ceiling.
Yeah, so you got a real tall ceiling. So in that case, as we talked about it, I don't know where it sits in the room, but it's probably not a big enough duct in that room. Probably. So you just add another duct. Okay, that's all you did. You could pull that one duct out and just make a bigger one if the duct is in, if that grill is in the correct location. If it's here and the exterior wall is here, it's in the correct location, then you can just run a bigger duct instead of adding a duct. Okay. So flexible duct, 45 CFMs, 6-inch duct 70, 7-inch duct 110, 8-inch duct 150, 9-inch duct 200, 10-inch 275, 12, 460, 1400, 650, 16, 800, 18, 1300, 2000, 1600. Now, let's go to a 10-inch duct on hard pipe, 400 CFMs. 275 on a flex duct. Why? Resistance in the duct. Static pressure. Know your static pressure. That's why you have a static. That's why you test your static pressure. Okay? An 8-inch duct, 200 and 150. Okay? Big difference. So now, if you calculate your duct work out and you're counting your CFMs, don't you have to know what you have? Hard pipe or flex duct?
Absolutely, makes a big difference.
Now, if you got all hard pipe in the house, you have to count it out and go, it's this side I need to add them all up to. If you have all flex duct in the house, you count them up on this side of what you're doing. Yep.
So I got a question. I got a plenum and I got like a 10-inch coming off. I got an 8-inch and I got a 7-inch, and they all break into Ys. Do
Okay.
I just count the
You
ducts
just count
coming
the
off
10, the
plenum?
8, and the, yeah, you count whatever's off your plenum.
Plenum. All right.
Yeah, because that is your release static pressure there, you know, from it. So, if you go to the other one we calculated was 1100 CFM with flex duct. So if we did a 10, a 9, 3/8, and a 6 that we did before, then you're doing 10, 4, a 9 is 7, 3/8, 7 and 600 is 1300, and a 6 is 1400 CFMs. So we have 1400 CFMs comparative to 1100 CFMs with the flex duct. So you gain an extra 300 CFMs of airflow with hard pipe as opposed to flex duct on the same sizes with that same scenario we had before. Return CFMs bases a 0.3 static pressure. A 10-inch duct, 220 CFMs. Well, wait, I thought you told me it was 400 CFMs. Well, look at your static pressure difference, 0.3 or 0.5 or 0.8, okay? Well, what size flex duct can I run for a 3-ton air conditioning system if I want the correct static pressure on my system? Well, 3 tons, I'm gonna run a 14 for that. Because a 14 is right, correct?
For flex?
Yeah.
Yeah.
No, that's 400 CFM for a return. You need 3 14s for a return. So if I just use static pressure and I only look at a 20-inch duct and flex duct is 1600 CFMs for supply. What is it for your return? 550. Why is your return only 550 CFMs, but your supply on a 16?
I mean, because your return is the negative pressure, right? So it's going to be like smaller.
It's
than-
less airflow,
Yeah.
less static pressure. Yeah. Standard grill sizes for 0.3 static pressure. Here's your formula: height time weight time 2 gives you the correct CFM for the return. 24 by 30 equals 720 times 2 is 1440 CFM, which is good for 3.5 ton. I can even go up to a 4 ton, which is only 160 CFM difference. 12 by 24 is 1.5 ton, 576, 600, okay? 2 ton, 20 by 20 gives you 800. 18 by 24, 864. 20 by 24, 960. 3 ton unit, 24 by 24 gives you 1152. 30 by 20 gives you 1200. 36 by 18 gives you 1296. 4 ton, 24 by 30, 1440. 2436 gives you 1728. 5 ton, 24 by 36, and a 12 by 12 or a 14 by 14 will give you 5 tons. So this is our duct sheet that we utilize. You should carry around with you all the time, and you should refer to back and forth, back and forth, back and forth until you memorize it. Okay? So it is now 4:12. It is lunchtime. We have now completed our third section of our heating system check and clean. Fall check and clean with gas heat, electric heat. We also went over duct sizes, return sizes. I gave you a whole bunch of stories. I rant, I raved. I talked to you about a whole bunch of different things, indoor air quality and how these damn systems work. Nobody can make you do the work. Nobody can make you go home and watch these videos over and over and over and over again. I am telling you flat out. You can't learn what I learned. You can't have the knowledge I have unless you put the time in. You can't download this information. You've actually got to go study it. You've actually got to make yourself a test. You've actually got to read it over and over. You got to watch the videos over and over and over and over. It's too much information for you to know off the top of your head, especially if you're just getting in this business. So I have trained a whole bunch of different technicians out there, and I will tell you the best technicians do two things. The first thing that they do is they become very thorough at doing the entire checklist, and they don't shortcut themselves, and more than anything, they don't shortcut the customer. They're not lazy. They don't skip over things just because they don't feel like doing it. That is one of the most important things. They buy the correct tools to get all the correct pressures and temperatures and, you know, all the different things that they can check. One of the biggest things that I will tell you that they will do in order to succeed is they will watch these videos just over and over and over again, because when I give classes and I teach you these things and I start asking questions in the class, I know you start to learn this stuff when you answer the questions properly. That's when I know you've been watching the video. If you came into this business and know nothing, and you're here for 3, 4, 5, 6, 7 weeks, and when we do a class and I go through the class and I ask you a question in that video, or just in something related to air conditioning, obviously, and the answer you give back to me is the answer I have been preaching and teaching and preaching and teaching, that tells me you're actually trying to learn. Because you're not going to get that answer from somebody else and him explain it the exact same way that I do. So when you give it back to me the way that I explain it, that's when I know that you're actually doing the work you're supposed to be doing. So I've trained a lot of people. The ones that have done it right have watched all the videos. They watch until they blue in their face, because they just keep learning. Because you can't watch them, you can't learn it. You can't learn all the CFMs. You can't learn the electrical. You can't learn about all the different thermostats that we teach. You can't learn all that shit in one setting. You got to continue with this over and over and over till it's just obnoxious, basically. So please watch them, take the videos, learn, get a career, improve yourself. The income comes later. It's the knowledge got to come first. Thank you very much.